Hey, welcome everyone. It's time for another Svelte Summit. We've got a bunch of interesting talks for you today. But before we begin, I want to give you all some information. So first off, the running time of the conference is about 5 hours, and that includes a 30-minute break as well. So there's a time for food or whatever refreshments you want to grab. After the break, we'll be running a meatball session. It's basically a chance for you to meet with other Svelte Lodas around the globe. There are some requirements to join. You need a microphone and a camera. And to join, you'll need to visit the link that we provide. So that's sveltesummit.com/meatball. And we'll remind you all once it's time as well. All right. And once you've joined, you'll be paired with a random person. So you'll get to talk about Svelte one-on-one for about 2 minutes. And after that, you'll be paired with another one. And that just repeats until we're done with the meatball session, pretty much. Last time we used this, it was a lot of fun. I got to meet all sorts of people from around the world, the US, Asia, Europe. So yeah, I definitely encourage you guys to join. All right. Second, this year we're running our first in-person Svelte Summit conference. So it'll take place in Stockholm in September, and it's going to be awesome. You can already buy tickets. More information about the event will come after this spring event is over. But for all of you that are here, we're running a small raffle. So if you buy your ticket before this conference is over, you'll be entered into a competition to win an exclusive slot at the speaker dinner that will take place before or after the conference itself. So that's a lot of fun. All right. Third, I'd like to thank all of our sponsors that have generously helped make this event possible. So a shout out to all of them. We have Monogram, GraphCMS, Vercel, Storyblock, Array, JavaScript DB, and Netlify. So with that said, let's get into the talks. So first up, we have Monogram's journey building an enterprise-grade app with SvelteKit. And without further ado, here's the talk.
When building an enterprise-grade, full-stack web application, the tech stack you choose matters. We imagined Raster without compromise or limitations. Our engineering goal was to build a fully featured enterprise application with minimal loading screens, no performance issues or crashes, and super fast reactivity to make a great end-user experience.
Raster is a modern image management solution, a Jamstack digital asset manager for a Jamstack web.
Instead of a messy solution with folders, Raster uses tags driven by AI to recognize what's in your image and provides tools to help designers and developers manage and integrate the images in a modern way. Additionally, Raster has built-in real-time collaboration backed by ultra-fast ImageX and Vercel-powered CDN to serve images quickly. Nonetheless, this is a long list of requirements. User authentication, complex queries to databases, stateful actions on the front end, powerful search interface, and lots of interfacing with backend APIs. And of course, with all of these, we could make no sacrifice on performance. To add to that list, we wanted a simple developer workflow. As Rich Harris said, frameworks are not tools for organizing your code. They are tools for organizing your mind. A simple developer workflow means less boilerplate, which means smaller bundles and less bugs ultimately. So Monogram spent time and energy researching the best tech stack to build Raster. We made fully functioning prototypes in both Nuxt.js and Next.js, but had two fundamental issues. First, performance. While we love Vue and React for most apps, the virtual DOM simply made Raster feel sluggish at times, especially when viewing lists of thousands of images. And second, simplicity. Both Vue and React have relatively complex developer experiences that ended up increasing the bundle size of the site. which leads to a slower end user experience. At Monogram, we always want to use the best technology for any task, whether it be a simple website or a full-scale app. So, looking at Svelte's benefits like the built-in animation library, its intuitive stores, lightweight package size, endpoints with SvelteKit, and super fast Vite development workflow, we quickly realized the potential that Svelte had to make Raster amazing.
We prototyped a new version of Raster in SvelteKit in days, not weeks, despite this being our first production SvelteKit web app. It's no secret, Svelte is incredibly intuitive for developers, so we were able to ship much faster, especially when paired with Vercel.
Because of all of Svelte's built-in benefits, Raster is able to have features that set it apart. We fell in love with Svelte stores. Stores let us easily share information across components and have them update in real time, without a bunch of boilerplate code. We've actually integrated them with Firebase's snapshot listeners, which is what allows us to have real-time data across the app for multiple users without having to make multiple queries or making our front-end code too complex. Combined with Svelte's $sign reactivity syntax, Svelte stores allow us to always use the latest data while being impressively performant. We also use stores for user authentication, which allow the whole app to feel like a spa. Even when changing workspaces, the browser never performs a full refresh, making Raster feel wicked fast.
Additionally, Raster demands lots of backend interaction. For authorization, performing a search, or uploading hundreds of photos at once, we needed a super fast backend. We utilize SvelteKit's endpoints to make fast API calls that live securely right on our production server. When you create a new view in Raster, for example, the image URL for that view is cached and ready to be deployed in seconds. Or generating a unique and secure Algolia search key, for example, is just one call to the endpoint away. This gives a powerful command palette right at the fingertips of our users.
Additionally, we knew that while Raster's power users would love the web app, they might want something more performant and integrated in their machine. So, with SvelteKit's secret weapon of adapters, we set out to build a desktop app from our existing codebase. While other frameworks would require using complex export commands and weird management of build workflows, we simply used SvelteKit's adapter static and had our desktop app running with changes only in our Svelte config file. And because of Svelte's performance and small footprint, Raster's desktop app is more performant and lighter than most in its class and uses much less RAM. So, with the same codebase, we're able to power our web app using the Vercel adapter and our desktop app with the static adapter. SvelteKit makes it easy to switch between. Then, we used Vite's intuitive handling of environment variables to add conditional logic to make the desktop experience even better, like having a translucent sidebar that feels at home on macOS. And lastly, we love Svelte's built-in animations library. Despite being only 1 kilobyte, the animations on Raster never skip a frame and make the app feel buttery smooth. We were able to integrate all of these features into Raster without sacrificing performance, both load time and front-end performance. Just navigating around Raster feels amazing and intuitive. No loading bars, no spinners. Everything just works. Now that Raster has launched in private beta, we are confident that Svelte was the right tool for the job. Everything is really fast and lightweight, while supporting every feature that we imagine, and more to come.
Because of the innovation Svelte has brought to the web, Monogram proudly sports Svelte and its development on Open Collective. If you'd like to use Raster for free as an early beta user, please drop us your email at raster.app.
What a great talk. We always hear about Svelte and SvelteKit not being ready for enterprise. Well, here's your evidence that it actually is. So yeah, great job, guys. Also, the production value. Wow, that was a great video. So from one topic to another, and it's an important topic: accessibility. Josefine is going to show us some cool techniques to help figure out if there are any issues with your website. And I think we might even see the Svelte Summit website here. So here's Josefine.
Hi, everyone. Thank you for coming to my talk. I hope you're enjoying Svelte Summit so far. My name is Josephine. I'm really glad you're here. And today I would like to talk to you about web accessibility when it comes to Svelte. I'm part of the developer relations team at Storyblock, and at Storyblock, we're basically providing a headless CMS solution and trying to make developers and editors happy at the same time. And I just got into web development relatively recently after switching careers. But actually, web accessibility was kind of ingrained into my career from the start, I guess, due to the nature of my first job. And I feel like that's a topic that's way too often still overlooked or just an afterthought. So I was super thrilled when I heard that Svelte was said to be accessibility first, because in my opinion, that in itself is kind of a cool statement. And that's also the reason why I decided to give Svelte a try, to see basically if that checks out. And basically, that's also what we are going to do today. So we're going to have a look at Svelte's compiler warning, what kind of errors they are catching and which ones they might be missing. And also, more importantly, what we as developers can do to bridge that gap. And so we'll get started with the compiler warnings and now have a look at what they're doing. So if you have built anything with Svelte lately, you probably noticed these accessibility warnings that you get. For example, if you are creating an image element and you forget to add an alt attribute. And there are a number of these warnings that are run at compile time and check for accessibility issues, mainly focusing on individual components. For example, we have the autofocus. So if you try to set an autofocus, for example, to an input element, you get a warning because that's considered really confusing and generally not good practice, as it kind of messes with the user's workflow through the page. We also have warnings for tab index. So that's quite similar. If you try to add a positive tab index, so for example, 1, that will kind of raise this element above the normal flow that you would go through when you're using a keyboard to tab through the page. And unless that's like a complete edge case, that's something you should totally avoid because it's, not very expected behavior, I guess, from the user, and that will just confuse them, sighted users as well, but especially if you're depending on assistive technology. We also got required attributes. So again, these are kind of course, considered best practice in general when it comes to HTML. So things like I already mentioned, the alt tag, or adding hrefs to an anchor element, or having the language attribute in an HTML element, things like that, or captions on a video, for example. They provide context to the screen readers, for example, that use this to navigate the page and give the user all the information that they need. So if these are missing, there's a lot of important information for context missing. And another kind of warning that we have is for semantic structure. So I said before, we're focusing mainly on individual components, but here for the fig caption, for example, that's supposed to be wrapped in a figure element. And here it's looking at the direct semantic structure and gives you a warning if you miss that, for example. This is all really cool. And I was really glad to find these. It's quite detailed, and it's really nice that they're already letting you know if you're kind of violating these best practices, because a lot of these general HTML attributes are super important especially for screen readers and for keyboard navigation. However, you're probably sensing there's a but coming. That's of course not all. There are a couple of things missing. So mainly most things that go beyond the structure or the structure of individual components. So we saw there the fig caption. That's kind of one of the few that identifies a little bit overarching structure, but things like, are you using the headlines in a hierarchical order? Is there just one H1? Is there just one main element, for example? These are also things that are really important to screen readers and for keyboard navigation. And that's something that cannot be covered. Or what kind of landmarks are used? Are they used reasonably? Are there maybe more suitable HTML elements that you could be using to give more context and more information? Is the tab order correct? Can I tab to every single element on the page that's needed? How is the page flow? And also visual things like color contrast, for example, which is really important to make all the parts of the page visible, both for sighted and visually impaired people, but also for situations like you're in really bright sunlight. And of course, you need higher contrast on your page to make it visible. And then also things like motion. So if you're sensitive to specific animations or like flickering of the light, that's something that it, of course, can't detect. But not to worry, there are a couple of things that we can do, and we're gonna look into these now. So what can you do to bridge the gap as a developer between what the compiler warnings already are checking and what's maybe still missing? And we're gonna have a look at checking for semantic HTML, the tab order, and color contrast. And we're going to have a look into that. So I'm going to show you a couple of tools. However, I have to say I have no affiliation with these tools whatsoever. I just liked them and got to work with them a bit. If you have any other tools that you are super happy with or that you would like to share, I'd be delighted to learn about them. So please feel free and reach out. And I'm going to move over to the browser and we're going to have a look at some of the tools. So we're going to start off with an plugin that I installed. It's the Dev tools. I can now open them here in my browser. And they basically enable me to run a test either on my entire page, which I'm now going to do, or just on a part of it. And it gives me a very general check of the page and shows me different kinds of issues and tests automatically. And so, of course, this is an automated test, right? So you will need to check for them, and just because you pass doesn't necessarily mean your page is 100% accessible, and other way around, of course, but it's a good first indication. And what we can see here, for example, okay, so there are 13 issues that need a review. We can then go ahead and skip through them. So for example, here it mentions color contrast. I can highlight it and then have a closer look at this. And I'm assuming right now, because white on what looks like black to me should be sufficient, but this is something that then we could investigate. Okay, so what element is it having trouble here with? I can inspect it in the console, or I could even go and learn more about it if I wanted to find out what kind of requirements I am missing here. So this is something that gives you a really good first first kickoff, so to say, but 13 issues. If that's all, that's already pretty good. And that's a good start. And now if we wanted to go a bit further, we could also have a look at the Web Disability Simulator. This is also quite interesting, especially when trying to figure out, for example, design decisions or usability, because here I can simulate different kinds of impairments through the simulation. So for example, I could go for sight and then say, okay, I want to see what people with color blindness experience my page like, and I can then go check it out. It looks, of course, very, very different, but it's still, everything is still readable. So that's a pretty good start. I could also change this, for example, to sunshine, where you need a lot more contrast, but still things are visible. The images here are a bit brighter, but generally that looks quite good. So this is something you could play around with a bit to get an impression. Of course, this is not 100% accurate. It just gives you a first idea of what different kinds of user groups experience your page as. If you want to go check out the colors a bit more in detail, you could also go ahead and use a color contrast checker. So they're generally, well, there you see here at the bottom, there are 3 different kinds of levels that you could pass. So, well, there's 1A that's not listed here, and then we have AA and AAA. And they have different requirements for different sizes of the headline, for example, of the test. But I could select a color here and check the foreground against the background, or this is my background color, and then the foreground should be this pink. And I can see here I have a score of 8.13. So that's good. You see here we're passing all the different requirements. For AA standard, I think 4.5 is required. So we're making some good, have some good contrast here. So you could go ahead and check all the different colors that you have in your color scheme and check whether the contrast is enough to meet the requirements that you are looking for. And then we have one last thing I want to show you, which is the Tab Ally. I can run that tool on my page, and it's simulating what the tab order on my page is like. So of course I can, and I recommend you to use the keyboard to tab through your page and see what an interaction would look like without a mouse, for example. But if you want to visualize that and make sure that you haven't missed anything, you could also go ahead, use the tool like this, and it will show you where your user will land when tabbing through the page. It will reach all the interactive elements, and then you can check whether this is a kind of a logical flow, so to say. And you can see if all the links that you want to be reached are reached. It's quite useful as well. Yeah, that was already it from the tool side. I will go back to my presentation now. And just to recap, if you have successfully resolved all your compiler warnings and are good on that front, you can go check, for example, the page structure with a tool like the XDevTools, for example, and have a look. Okay, so how's the structure? Are you using the right landmarks? How's your layout? How are the headlines? You can go ahead and check your design against the color contrast requirements that you want to comply with. At least 4.5 as a contrast is recommended. And you can go ahead and either manually tap through your page or use a tool to visualize where your user is going when they use a keyboard on your page. So in summary, I guess we could say, well, the compiler warnings, they're not necessarily a shortcut, but they're definitely a great start, especially at such an early age for a framework. And it's a really good to raise awareness. It's a cool statement, and it's a great start to continue learning and investigating what we can do in terms of accessibility from there. That was already all from my side. Thank you so much for coming to my talk. I would love to hear your thoughts on Svelte and accessibility, feel free to reach out to me either on Twitter or via email. And yeah, enjoy the rest of the conference and have a great day.
That was a lot of nice tools that I've never heard about before. I hope you all learned something from it. It's an important topic, like I already mentioned. But yeah. So next up, we actually have a live talk with the creators of the Svelte bot. If you haven't heard about the Svelte bot, it's what keeps us sane on the Svelte Discord in the Svelte and SvelteKit channels. But yeah, before that, let's see if we can find a short break, just 30 seconds or so. Hey, hello, Willow and Nayan, I guess. Do you guys have microphones?
Oh, you can call me Siri. Hey.
Yeah. All right. Hey, Siri. Hey, Willow. Willow, you're muted.
Hi.
There we go. All right. Cool. So let's talk a bit about the Svelte bot. So yeah, there you are. I think everyone can hear us now. Cool. All right. So what is the Svelte bot?
Well, it's what, cybernetically enhances our Discord server to, for a short description. It, provides auto-threading for the Svelte and SvelteKit help channels and a lot of, well, not a lot, but quite helpful stuff, other like doc search and tags. And you can see what it does on the GitHub repo, but we'll get into that later.
Yeah. So what's the history behind the bot? How did you guys start working on it? Who asked for it? Like what's the story behind that?
It actually kind of started from me messing around with Python 3.10. They had these match statements that I wanted to try for parsing commands. And I thought it would be cool if the Svelte Discord had the bot for doing these things. So I pitched the idea to Penguin, and he was like, "All right, we'll do it, but maybe later." And a few months later, here we are.
Yeah, nice. Yeah, it's definitely been a lot of help. So if let's talk a bit about the features. So most people probably know the auto threading one in the Svelte and SvelteKit channels. But are there any other features that you've built?
Yeah, so the threading is probably the main one. But we have tags, which is pretty big. It allows you to so for a lot of people have this similar questions, and if we save that as a tag, it allows us to just send the same message over and over again without having to retype it every time. And then we also have documentation searching, and GitHub issues and pull request stuff. And we briefly had thread statistics, and that might make a comeback at some point.
Yeah, so that was the you could earn points, right?
Yeah.
Yeah. That was a fun feature. All right, cool. So do you guys have any plans for the future of the bot? Like, are you going to add any new cool features?
Well, actually, the plan is to remove features, as more from Discord come in, like the forum channels and more moderation commands and whatnot.
Yeah, that makes sense, I guess. So Brittney is asking for a link in the chat here. I believe the repo is on GitHub, right?
Yeah,
Maybe we
it's
can
under
post
pngwn's
that.
account. It's pngwn/SvelteBot.
Yeah, so I'm going to drop a link in the chat here. All right, cool. So there's the link, and yeah. So what's the deal with the mustache? Why does the bot have a mustache?
I get they grow up quite fast nowadays, really.
Oh, right.
Yeah, no.
How long did you think about that joke?
That's too long. No, we just the Figma file for the SvelteBot logo is like at least 15 iterations. We just had a lot of fun trying to come up with something.
Yeah. Cool. All right. I think that's it for the SvelteBot talk, or cybernetically enhanced Discord server bot thing. That name is a mouthful. All right. Thanks for coming on and talking about the bot, and we'll get back to the other sessions in a bit. All right. See you guys.
Bye.
Bye.
All right. That was great. If you haven't seen the SvelteBot or the mustache, you should definitely check it out on the Discord, discord.gg/svelte. And there's also a lot of people on there talking about this event as well, if you want to do that. But let's see if we can find another talk. So next up, we have a talk about Svelte native, which is not something we hear a lot about. So let's see. All right. All right, here we go.
Hi, Svelte community. Thanks for having me this time again. My name is Kyohei. I have been a software engineer for 14 years or so, but being in front-end field just recently, like 2 or 3 years. Today, I'm gonna talk about Svelte Native, a framework that enables you to build native mobile apps for iOS or Android. I assume most of you have heard of it, and some of you might have actually tried it. I myself have tried it recently, and that was so fun. I really loved and they would like to share how smooth I could switch between Svelte and Svelte native code bases in development. So this talk is gonna be for you if you're interested in Svelte native in your product. Before jumping into the topic, I will share the context that I decided to use Svelte native. I'm currently working for a startup called Hide, and they're building a unique platform where you can take back your personal data from the megacorps, get rewarded by participating automated analytics service if you'd want, while keeping your data secret to anyone, even to us. We have one challenge here. We rely on OAuth, but at the same time, we must not touch the authorization code and access tokens in the process on our server side. Otherwise, we would be a middleman breaking users' privacy. To overcome this, we had to build OAuth client to be publicly audited and importantly, run token requests in the confidential Kubernetes cluster that accept only publicly audited container images. As you see, this is a little involved, so I had to prove that the concept would work in advance, and did successfully with the browsers, but as a matter of business, we needed to make sure this would work with mobile apps as well. Also, I didn't want to expand the technology stacks too broadly for our teams. Otherwise, our small engineering team, which is 3 developers including me, would be overloaded by the context switches between them. If we could write web and mobile both in Svelte, how would it feel nice? That's why I decided to try Svelte native. So what is the Svelte native? It is a framework for building native smartphone app with Svelte components. In the context of React ecosystem, you'd have heard of React Native. As the name suggests, in the overview, they share most of the concept, but allows you to write user interfaces, mobile or native apps with familiar syntax and concept in web. Biggest difference here between Svelte Native and React Native is Svelte Native is also a compiler. In contrast to React Native that resolves JS logics at runtime, Svelte Native does most of the job at compile time, so it allows more slick user experience. So, I think 2 of the most interesting selling point or value of Svelte Native are developer ergonomics that comes from the Svelte syntax and concepts and the reusability of the code. I have been using React Native for quite some time, mostly for gig works. In those days, there was a quite common misconception in clients over there about how much code would actually be reusable between web and native apps. When I was new to React Native, I also naively assumed that most of them could be reused, and it was true in theory, but less in reality. So I would discuss mostly about the code reusability here, since I believe great ergonomics of Svelte syntax is well established and discussed already in this event. Svelte Native supports HTML, Tailwind, or many other things you love in web development with Svelte. Let's see how Svelte components in both contexts look similar. This is an example of the components taken from the Svelte Native tutorial. Look at how it is nicely formatted just by copying pasted from VS Code to Keynote. It's really in the same structure with Svelte. Let's compare this to the similar example from the Svelte tutorial. You find they look very similar, don't you? Actually, both can have a tuple of the markup, script, and style block. They can both recognize JS or TS TypeScript natively. But at the end of the day, they rely on the different technology, namely DOM for one, native components for another. This makes it hard to reuse code as much as in the common misconception I mentioned here. Since if a components have DOM elements inside, it cannot be used in Svelte native that run outside browsers, and vice versa. Here is simplified version of dependency graph. DOM elements or native components are in the bottom of the diagram. They cannot coexist, so more components contain them, less can be reused. To achieve maximum reusability, let's move code. We would need to move code to higher portion. The lowest hanging fruits are the pure business logics. Pure business logics. As Svelte FAQ mentions, they are likely to be the first ones to be separated. In our cases, long before native apps required for us, we had separated already those out of the components to use them in the endpoints in Kit and to make them easier to test. We had already organized the modules to be placed either under DataLib or DataLib client or DataLib server so that they can easily find out in which context modules should be used. So with this background, it was straightforward for us to assume the modules under DataLib or DataLib client would work on the native context. And that's where pure business logics are placed. I hope junior engineers also can enjoy this talk, so I want to brief what business logic looks like. This is the example of the component that contains business logics, taken from the tutorial as well. This part, I'm sure no one would find any meaningful interpretation in just A plus B, so let's give them a little more concrete name. So then, this becomes a BMI calculator, and as you would understand any technical concern, any technical concerns wouldn't matter to definition of BMI. They will be calculated with this formula, weight over height squared, no matter either on client or on server side. This is an example of business logics. Actual scope of the term highly depended on the context or culture or school of thoughts on architecture, but ideally, they are supposed to be a function or a class that doesn't affected by other technical concerns like networking, data persistence layer, or more importantly in this talk, user interfaces too. They should be determined no matter where it gets executed, either browsers, server, or mobile apps or any other context. That's why they tend to be called with pure. There's no clear distinction between UI concerns, user interface concerns, and pure business logics. It's not unlikely that you implement business logics unintentionally into a Svelte component. This example also shows how a business logic tends to be intertwined in the UI concerns. I like referring this as a discovering business logics. You can sculpt out a business logics like this, just like you discover a sculpture in a marble. In the same analogy, you sometimes unintentionally build a marble which a sculpture or a business logics already is in. I'm sure you've done this many times ever. It's also called something like refactoring or architecting. They are all about extracting a business logic. You extract them to organize code bases well and get better sites on it, but also it helps you reuse it in another context. This applies here in the same way. Okay, back to the topic. Once pure business logic has been separated, data fetch should come next. Since fetch is available in native script and Svelte native, it is also trivial to use helper class that use fetch written for Kit in native counterparts. Actually, I love this part most in Svelte native. I hadn't worked on the mobile devs these days, but when I was there, I remember people used to struggle to find or decide which is a good HTTP client to use on the native apps. I don't know what it is like recently, but having Fetch built in JS runtime feels a huge win for me. So once you have a thin data fetch layer that depends on just fetch and business logics layer, you're going to be able to reuse the data fetch layer and the APIs behind it, hopefully written as the endpoint in the kit itself. And the components. But the bottom line first, I don't think it's good assumption that you can reuse Svelte components written in Svelte native. I would explain the possibility in theory first, and the reality that's where it's not and why. In theory, some components seem to relatively easier to migrate, those which are abstract enough not using HTML element, DOM element directly. Take an example in the tutorial again. This just imports another Svelte component and doesn't depend on anything else itself. So if you'd inject corresponding version of nested components called nested for web and native respectively, they seem would work in theory. The challenge here is to reuse the component that directly contain DOM elements. It wouldn't be impossible to abstract them away. If you would inject corresponding version of nested component called nested for web and native respectively, they seem would work in theory. Challenge is to reuse the component that directly contain DOM elements. It wouldn't be impossible to abstract them away to the component that share the same interface but use the HTML elements or native components inside a proprietary like this. But I don't recommend to do this because of too low ROI. In reality, components in Svelte native app would be like this. It's unrealistic to make wrappers for all of them, all of these native components used in here. Especially you are interested in Svelte native because of limited amount of the resources in the first place, like us. In the end, those are the exact concerns user interface library is trying to solve. They shouldn't be abstracted away. They shouldn't be abstracted away carelessly, or will be too leaky abstractions. I hope they could be like mobile webs where we had to develop separately long ago, but can be single complex nowadays thanks to responsive CSS. But at least at this moment, native components are too different from the DOMs to be unified. Unfortunately, writing native components in Svelte native is fun and effective enough. It might feel like non-dry at the beginning, but you'd gain a good balance of dryness and optimization, not too eagerly. So finally, we would be able to reuse 3 kinds of the code out of the 5 boxes in this diagram. 60%, amazing! It's joke aside, but this is worth knowing for when you want to assess how Svelte native would make native development easier. Let me conclude. Svelte native is a framework for building native apps with UI components written in Svelte. It's a thing that I would call it as a plugin of a native script if we would lower the barrier for you. Svelte native would be good fit if you are in a small startup or do hobby project, and also if you love Svelte economics and would like to write similarly must be great fit. Combining with the web built with Kit, most of our code bases are written in Svelte mindset. Less context switch means to deliver more value quicker and better. Great. Unfortunately, we hadn't released the app yet, but we'll do really soon, like in May or early June. If you'd like to try it out, feel free to send a private message in Discord. And really love to get feedback. I would invite you to internal test. So, thanks for joining this talk. Happy native hacking with Svelte. Bye bye.
Svelte Native. That was really nice. I've always wanted to try Svelte Native for something that's more real than just a small, tiny side project. I don't even remember if I've tried it properly for a side project, but I'm definitely going to do that after I've seen this talk. All right, so that was Svelte Native. From native to regular Svelte, I guess. Let's see what Scott Beale has to say about complex stores. So this talk is pretty advanced, but it's also pretty cool to see what you can actually do with custom stores. So here's the talk: tackle complex async behavior one step at a time with Svelte stores.
And welcome to my talk on tackling complex async behavior one step at a time with Svelte stores. My name is Scott, and I'll be covering how we can use custom Svelte stores to write easy to read, maintainable Svelte, even if we have complex interdependencies between asynchronous data. First, I'll start out with a little bit of information about myself. I am a full stack developer who has been in industry about 5 years. I work at Square in ecosystem engagement. And what that means is that I work at the intersection of many different teams' interests. This puts me and my team in a position where we are needing to aggregate data that is published across Square's ecosystem. This leads to some complicated order of operations issues when it comes to retrieving data, where in order to get data published by one team, we need to find data from a different team and a different service. Our current work is in Svelte, and it took several different iterations to arrive at a good solution for handling these data relationships. So I'm going to be covering the patterns and principles we learned to keep our code as modular, modifiable, and self-documenting as possible. So first, let's kick things off with a short clip.
First, we have to call the bingo service. See, bingo knows everyone's name-o, so we get the user's ID out of there. Then from bingo, we can call papaya and MBS to get that user ID and turn it into a user session token. We can validate those with Ultima, and then, once we have that, we can finally pull the user's info down from Raccoon.
Now, does that seem relatable to anyone? That's from the excellent sketch, Microservices by Krazam. It satirizes back-end development, but in front-end web dev, we face similar problems all the time, particularly those of us who work in large ecosystems. We're grabbing auth tokens from one endpoint so we can pull user permissions from a second, then using both of those to hit a third and fourth endpoint, and so on, as users move throughout our application. It's really not an ideal world for our development experience, but it's the reality of having so much data at our fingertips, just not necessarily designed for our use case specifically. So what's our plan? If we don't approach these situations with a solid and structured plan that can be applied both to today's data conditions and tomorrow's, it is easy to inadvertently create a rat's nest of chained promises or asynchronous functions that is difficult to read and even more difficult to keep reactive and maintainable. Over the course of this session, I'm going to dig into how we can break apart complex asynchronous problems using custom Svelte stores. For any viewers who are relatively new to asynchronous JavaScript, things might get a little confusing when we get into the nitty-gritty of things. But luckily, all of the solutions that we will go over here are contained in the open source Square Svelte Store package. So stay tuned and we will arrive at a set of tools that you can use to ensure reactivity, enforce best practices like lazy loading, and enable our stores to simply manage our async data. But first, let's cover what is a Svelte store. Well, there's really two ways you could think about it. The first is the way that most of us usually think about it from day to day. A store is a container for a value, and when that value updates, so does anything that subscribes to that store, whether that's a component, a reactive statement, or another store. But another way to think about it is that a store is just an object with a subscribe function. You can pass a callback into that subscribe function, and whenever the value of the store changes, the new value is passed to the callback that you provided. Let's look at some design properties that stores enable that make them valuable for managing asynchronous data. The first is that stores are reactive. A store updating will cause any subscribers to update without any additional work. This results in particular properties for how store data flows through our application. Data trickles down. Changes flow in one direction, from parent to any children to any grandchildren, and so on. However, requests for data bubbles up in the opposite direction. Subscribing to a store causes it to subscribe to any parents it has, and those to any grandparents, etc. This results in the ability to isolate data. A derived store only cares about the data of its immediate parents. Subscribing to the store subscribes to the parents, but how those parents get their data does not matter to the derived store. This makes stores very maintainable, where you can swap around data relationships in one area of our application without affecting our other stores. Finally, we have the concept of lazy loading. This applies to asynchronous data, where we only fetch data from an endpoint when we need it. But this is also how stores operate. Stores don't begin to calculate their data or fetch data from any parents until we subscribe to that store. So when we write our custom stores, we are going to want to tap into that property and only load asynchronous data when the store is subscribed to. Now, default stores are capable of handling async data. So you may be wondering why we need custom stores to begin with. Well, consider an example where we pull a list of items from an endpoint and iterate through those values in a component. We want to display a loading state before the data is ready. So how do we know when our data is ready? We need a way to delineate between a store that has completed its asynchronous behavior and one that has not. So we can work around this and extend some store functionality to deal with this situation. We can check the value of the store, and if it's still the initial that we provided, we can assume that it has not loaded yet. However, this approach is fairly fragile. Different stores might require different initial values that are difficult to use this approach with. And this kind of check is very poor for error handling. Another approach would be to pull async behavior out of the store and put it into a promise that you can await in your components. But this breaks isolation. To use our store, we can't just worry about the store itself anymore. We have to consider this external promise and make sure that that has resolved before we can use our data. This starts to become very onerous when considering derived stores. A derived store might have data that originates from several different endpoints, but goes through several layers of derivations. In such a scenario, the simple question of, does my store have the data it needs, requires a good deal of hard to maintain bookkeeping to answer. So without further ado, let's start digging into how we can use custom stores to create a more streamlined and maintainable solution. First, let's take a look at the example custom store given in the Svelte tutorial. In a function that returns a store object, a writable store is created and the subscribe, set, and update functions are destructured from it. Those functions are then used to create a new set of functions that are returned in an object. Since this returned object has the same subscribe function as the writable store we created, they actually reference the same store value, and thus each is an extension of the same store. However, instead of exposing a set and an update function, the return object instead exposes a different interface for interacting with the store. With this general premise and technique, we are able to add and restrict functionality to our custom stores. Now, let's look at how we can use this in order to manage async functionality. Now, this looks fairly complicated in comparison to a naive approach of dealing with async data. But what we are doing here is stuffing all the complicated overhead that we discussed earlier into a reusable store. Once we start creating stores, our application code will be much cleaner and more maintainable. Let's look at how this works. Like a regular readable store, this async readable store takes in an initial value and a function that sets the value of the store when it is subscribed to. However, this load function is an async function that returns the loaded value of the store. Or in terms of promises, the load function is just a function that returns a promise that resolves to the loaded value of the store. Let's skip down to what our custom store returns. Like always, we provide the subscribe function that makes this a store, but we also provide load and reload functions. Calling load on this store will give a promise that resolves to the store's value. We'll come back to the specifics, but first let's look at how we can use this in our components. Here we create an async readable store that represents our user's name. To create it, we just need to pass in an async function that will fetch and return the data that we need. In our template or anywhere else, we can await username.load, and this will resolve once our store has its loaded value. So let's jump back in and see how that actually works. Inside our main function for defining an async readable store, we defined another function, load value. This is what calls the load function provided during store creation. However, the load function is only invoked the first time load value is called. This means we can call load value as many times as we want without worrying about inadvertently making network requests. This way, we can load our store in as many places across our application as needed. Load value takes in a set callback that we can get when we create our store, and this lets us set the store's value to the result of the load function. When we create the store, we provide load value to be called when the store is first subscribed to. Taking this approach means that data is lazily loaded automatically simply through the act of accessing the data or calling load on the store. So this setup that we just covered provides all of our design properties except for isolation. If we have stores that derive from our async stores, how do we tell if the derived store's data is ready? Well, we can look at its parents and whether those have loaded, but that means we have the same problems with bookkeeping that we have with default stores. We need to do additional work every time you want to wait for a derived store to have its data by manually auditing where its data enters your application. Let's think about a way to circumvent this. If you spent a little bit of time, you might realize that we are already telling our code where a derived store's data is coming from. And we do so when we specify the store's parents during creation. So let's see if we can tap into this by using another custom store. So here is our custom store. Just like a derived store, it takes in a collection of parent stores and they function to map the parent store's values to the value of the derived store. The layout should seem familiar from our previous custom store, but here we are extending the functionality of a derived store instead of a writable one. This means that we get all of a derived store's functionality plus any that we add to it. Like before, we define an internal load value function. In this case, rather than loading itself, it loads any parent stores and then uses the mapping function to give us the value of the derived store. To accomplish this, we use a load all function that calls load on any parent stores. Let's jump into how that works. Here's the load all function. It takes in a collection of stores and then maps that to those stores' load functions. If a store passed in doesn't have a load function, we instead just get the value of the store. Then we await all of the parent's load functions to get us a collection of the parent store's loaded values. Since calling load on our store awaits load all of the parents, calling load on one of these stores will await any async readable parents and then give us the value of the store. What's more is that because a loadable derived store itself has a load function, we can derive from another derived store, and thus load ultimately awaits the origin of the asynchronous data. In this way, we are bubbling up load requests using the same structure that subscriptions bubble up in normal stores. So let's take a look at how we can use this in a component. First, we're going to define two stores that represent an array of letters. One is defined synchronously, and one fetches from a remote source using an async readable store. We create a loadable derived store that combines these two arrays, and then a final loadable derived store that represents the length of the combined arrays. With our custom definition of our loadable derived store, we can use them in the same way that we use async readable stores. And thus, we have achieved isolation. When we implement and use num letters, we only ever need to concern ourselves with the data that it needs immediately. In this case, all letters. We don't need to care that this data ultimately comes from one synchronous input and one asynchronous input. We've isolated our store from that. And this lets us use stores as small building blocks that can be independently maintained and modified as our application grows. What's more is that since a loadable derived store is purely an extension up to regular derived stores functionality, we can safely replace all usages of derived stores in an existing Svelte application without breaking anything. This enables us to add async readable stores wherever needed in our app, and all of our derived stores will be compatible with them without any additional work. That's the pattern that Square has adopted in developing Square Svelte Store. This open source project can be dropped into your application as a replacement for the default Svelte Store import. It includes all of the functionality of Svelte Store, but also extends that with new stores and new properties on existing stores. Included is the async readable store we covered earlier, as well as a re-export of derived stores to include the new functionality that we covered with loadable derived. Also included are two additional types of custom stores, async derived and async writable. We'll get to their capabilities soon, but first let's start putting together what we've learned so far. Let's consider an example with a degree of complexity. Using our custom stores, we will break apart this example and isolate individual steps. Imagine we have a social media app that lets users share and view blogs. In a sidebar, we have a list of shortcuts to the user's favorite blogs, along with a blurb from the blog's most recent post. We would like to test a feature with 5% of users where we can also provide a few suggested blogs alongside their favorites. As a user makes changes to their favorites, their suggested list also updates based on their indicated interests. To support this, we have a number of endpoints. A personalization endpoint provides a list of the user's favorite and suggested blogs. A preview endpoint lets us fetch a blurb for the most recent post of a given blog. A favorites endpoint lets us post updates a user makes to their favorites. A testing endpoint lets us determine if the user should be included in the feature test. And finally, a user endpoint lets us gather user info, including a token for identifying the user when calling other endpoints. We've got some challenges here. We need the user's ID before we can take any other step. We need to query the testing endpoint before we will know whether to display suggestions alongside favorites. If a user makes changes to their favorites, we'll need to check for new personalization data. And whenever a user's shortcuts update, we'll need to update our preview blurbs to match. Without a good plan, this could get messy. However, by applying our custom Svelte stores, all we need to worry about is one piece of data at a time. Here is a code sandbox with a fake backend built out with mocks of the services that we just outlined. Additionally, we have a component that we can use to display our favorite and suggested blogs. First things first, let's start building out our stores so that we can display a list of our users' favorites without worrying about the other requirements. We can get favorites from the personalization service, but first we need a user token. Here is our user token store. It's very simple. We use an async function to fetch from the user service and retrieve the token from that data. Now, our next step is, how do we get data from our personalization service? An async readable store lets us grab data from an async source, but we also need to use the value of this user token store. For situations like this, we will use an async derived custom store from the Square Svelte store package. This async derived store works very similarly to a regular derived store, but it lets you use an async function to set the value of the store. An async derived store can derive from both async and regular stores, but will only load after any async parents have finished loading. This means that we can safely use and load this store without having to worry about order of operations. The store handles that for us automatically. Once we have our user token, that will be used to fetch the user's personalized blogs. Once we have our personalized blogs, we can use a derived store, which includes the loadable features that we added previously, to represent our users' favorite blogs. This lets us start displaying favorites to our user. Since our custom stores handle all of our order of operations for us, all we need to do is await the data that is relevant to our current task. Here, we will await favorite blogs, and when that has loaded, we display them using our blog shortcut component. Now, let's add suggested blogs for users included in the experiment. We can create a store to represent the suggested blogs just like we did for favorites. Only now, we'll need a way to gate their display. To do so, we will once again need to fetch data asynchronously after we've fetched our user token. So we will use another async-derived store. Here, we query the service and grab the flag for the relevant experiment. Now let's update our component. Here we display the suggested blogs if should show suggestions evaluates as true. Note that we are using a load all utility so that we can await the 3 stores we need for our display logic. Our next step will be to support our blog previews. Here, we use another async-derived store to use our favorite blogs and suggested blogs data in order to create a series of calls to our preview service that will populate an object that maps blog IDs to the preview content. Now we are able to update our blog shortcut component to display these previews. We await blog previews loading and then use our blog ID to get our blurb. Note how our custom stores allows us to easily lazily load our previews. This means we can begin to render a user's blogs before we have finished collecting all of our previews. The last pieces of the puzzle are allowing our user to update their favorites and refresh their suggested blogs when they do so. For this example, we'll just cover dismissing favorites and not adding any. So what should happen when a user clicks to dismiss a favorite? Well, we could send an update to the favorites endpoint, and when that is finished, find a way to refresh our personalization store with the new data. The problem with this general approach is that our front end won't update to display the new set of favorites until those 2 async tasks complete. This adds undesirable latency between our user performing an action and when they see the effects of that action. Instead, when a user dismisses a favorite, we should optimistically update our front end immediately, and then perform the actions to persist their new list to our back end. What this means is we need a way to write to our favorite blog store and then send this new value to the back end. For situations like these, we can use an async writable store. So let's convert our favorite blog store. As an async writable store, this has all of the features of an async derived store. We provide a list of parent stores and can use those values to synchronously or asynchronously get the value of the store. However, just like a writable store, an async writable store exposes set and update functions that lets you modify the value of the store directly. When creating the store, we can pass in an async function as a third argument that will get called whenever we modify the store's value with set or update. This function will be passed the new value of the store and can be used to perform any async side effects that are needed. In this case, we will save the new list of favorites to our backend. Note that because we need the user token to save this new list of favorites, we've included a second argument in our function, and this will receive the values of any parent stores that we have defined during creation. This allows us to derive our writing functions in the same way we can for load functions for regular derived stores or async derived stores. Now we are able to set favorite blogs and have our front end update immediately. This also persists our changes to the back end. We can now dismiss our items. Our final feature is that after a user has modified their favorites, we need to refresh our suggested blogs in case the change to favorites has resulted in any updates. To support this, we are going to add a third argument to our personalized blog store. This Boolean indicates that this store is reloadable, which means we can call a reload function on this store to fetch new data. You can also call reload on any store that derives from a reloadable store, and doing so will reload any reloadable parents while leaving non-reloadable parents untouched. This means that we can call reload on suggested blogs as it derives from personalized blogs to get new data without worrying about making unnecessary calls to the user service, for example. From here, our modification to blog shortcut is simple. When we are done setting favorite blogs, we simply reload suggested blogs. Now, when we dismiss a favorite, we load a new suggestion. And that, in turn, will automatically load the new preview without any additional work or input on our part. With these tools under our belt, we can break apart even the most complex asynchronous data flows by isolating individual steps using these custom stores. For each step, we only need to worry about the data needed for that step and not where the data originates. Thank you so much for attending this session. Using custom stores to maintain reactivity, trickle down data updates, bubble up data requests, isolate data requirements, and lazily load from endpoints allows us to handle async data without additional overhead or bookkeeping. I hope the tools provided by the Square Svelte Store package will be useful in your development, and I look forward to growing this project with contributions from across the Svelte community. Stop by the README for more in-depth information about features, and don't hesitate to shoot me an email with any comments or questions. And with that, I'll hand things back over. Enjoy the rest of the conference and happy developing.
I think my brain just exploded. This was a lot. Pretty cool. Stores are just amazing. And I'm definitely going to have to rewatch this one because it was a lot to take in. It's a great talk though. All right, so we'll take a short 4-minute break or so, and then we'll be back with the next talk. All right. So we're back. We just had a short 4-minute break or so. And now we're ready for the next talk. And it's all about macOS web. I'm sure you've seen this around the web. It's basically a macOS desktop built in different web technologies, specifically Svelte at the moment. But before that, it was in a couple of other different technologies. And yeah, so we're going to hear about that. And let's go.
Hi, welcome to my talk about moving an app of mine, macOS Web, from React to Svelte. So, what exactly is macOS Web? It's basically a project I made for fun. I started 1.5 years ago, kept iterating on it, kept adding features until here I am today, giving a talk about it at this awesome conference with some really cool people. So, who am I? My name is Puru Vijay and I'm from Jaipur, India. I am currently a BTech student, but by the evening, I put on my hacker hoodie and get to work on Stack Blitz and open source stuff. And those of you who know me from Discord know me as this black and white sideways turned disgruntled cat. So, with that intro out of the way, let's get to the whole song and dance of the macOS web. Early days, React. Initially, the app was built with React, and the styling solution was done using Material UI's styles. This was only the case in version 4, and it was deprecated in version 5. And finally, if you see that dock animation on the bottom, that was done with frame on motion. Features of this are a really cool animated dock with a really cool animation and a static toolbar, completely non-interactive. For only 2 features and such little interactivity, the size should not be big, right? It was 146 kilobytes, minified and broadleaf. And that's only the JavaScript. So yeah, I was quite frustrated. But even then, the size was not the biggest issue. Network requests were. As you can see, we have a giant list of requests. This is the nature of Snowpack by default. Snowpack, even in prod, ships separate files as ESM, which is not great with these many files, as even with HTTP2, these many requests are simply not as fast as one single minified request or file. And finally, the dock animation was janky. Dock animation works by changing the width of the individual images. So changing widths of 7 images at once, listening to the mouse hover event, and then the actual width change causing relayout makes it drops a lot of frames. Hello, Veet. Around February of last year, I found out about this fun little thing you might have heard of, Veet. Veet is an all-in-one bundler / dev server / build tool combined into one little delightful package. Veet is very similar to Snowpack, but much more polished, and it bundles everything into a single file in production. Do you see where I'm going with this? Just moving to Veet reduced the bundle size by 16 kilobytes, and the network requests finally were just 2. If you think about it, just changing the bundler reduced so much, which is just mind blowing to me. And one of the bonus things, because of how Veet handles assets, it is possible to use the image by a path relative to public folder directly. With that feature, the code went from this to this. And because I followed the convention of storing the icons as the same name as key in the config object, I got rid of even the icon property. This is the final thing. So the code finally is simply this, and the usage is as follows. As you can see, just using Veet made quite a big difference. Era of React. In React ecosystem, the most recommended method to increase perf is to move to React. So that's what I did. And all it took was changing one single file, which is the veet.config.ts. All I had to do was install the preact.js/preset-white plugin from npm and replace the React refresh with the preact imported from @preact.js/preset-white. And it's done. This plugin automatically did the proper aliasing of React and React DOM to preact/compat. So I did not even have to change the imports or anything. It just worked. A huge shout out to Preact team for making it so damn easy. And the best part, bundle size went down by 37 kilobytes, and that brought it to 110 kilobytes. Of course, earlier the size was around 130 kilobytes, so the math does not exactly work out. The explanation, I had added a few more features which resulted in a bigger bundle size. But it's still a huge difference. Goodbye style components. So initially, as I said, the application was written with Material UI's style solution. Writing styles as JS objects is not fun, not at all. So after I moved the app to Preact, I also migrated the styles to style components so I could write some sane looking CSS. Folks, CSS as JS objects is just overrated. And bonus, it looks much better. Like it literally looks like some plain CSS, which is just really, it feels like home. It feels like home. It feels very comfortable. But it had its issues. So the issues, style components is just CSS in JS. So it was not really a great experience. Something about writing CSS inside the TypeScript files just feels wrong, uncanny. Another thing, it requires a VS Code extension. Remember the code snippet you saw before of style components? Notice the CSS in it was not syntax highlighted. This is true for VS Code as well. You need style components extension to get the highlight, intelligence, all the things that make CSS support great. And finally, the performance is just not great. By performance, I mean the runtime performance. Because style components create the styles using JS, it is always slower than just providing the plain CSS on demand. Of course, this point is not very important for this project as I never saw style components as a runtime perf bottleneck. But the issue was still there. And finally, its bundle size was 12 kilobyte, which is not really big, but it still nagged at me. And one of the things is that it does not minify. So what you're seeing is the final index.js bundle of the app. As you can see, there's a lot of minified JS, and then you have the raw CSS written inside the JavaScript. Frankly, it looks ugly and makes the bundle size bigger for no reason. Finally, I got rid of style components and replaced it with plain SCSS modules. And the results were good. The size went down from 110 kilobytes to just 85 kilobytes. But more than that, it also made it easier for the browser too. All that was needed now for the browser was just to parse the CSS in background and be prepared. The JS had no more control over the CSS, hence it was overall more performant than before. Finally, I was at a point where I could not make the app smaller by removing the smaller dependencies anymore. Those dependencies were just way too essential for the app to work. So finally, I resorted to code splitting the app away using React Suspense. Up until now, all the apps were loaded on the initial load only, which was not needed if you don't even open the apps. This here is the app Nexus component. Why the name Nexus? Nexus in science fiction and fantasy is a world between worlds, a room with doors in it to lead to other worlds. This is what app Nexus does. This component is responsible for loading the writer when it is requested. This move brought down the bundle size down immensely. Now it was just 62 kilobytes on first load, which is just really, really good. It's literally 2.5 times smaller than the initial version, which was at 146 kilobytes. So summarizing, these are all the tricks I applied to reduce bundle sizes. Move to Preact, style components to CSS modules, code splitting, and most important, get rid of dependencies. And here's the dependencies until now. These are the lowest this project has ever had. Now, This is Svelte Summit, and I still have not gotten around to Svelte. So here it is. The golden age of Svelte. Finally, we are on Svelte. Let's talk about it now. On 12th of August, I started migrating the app from React to Svelte. I started with copying the plain JS files first and then the React ones as .svelte files. I would paste the content of the React file and start removing the JSX specific code from it, file by file. And by the night of 13th, I was fully done with the refactor. Everything done in just 2 days. This is a giant benefit of the modern web development. We all argue how one framework is better than others, but in the grand scheme of things, all are similar enough. And it is a boon for people like me who like to migrate things over all the time. So how exactly was the process? It was hard. It was very, very hard. It was a super grueling process, very tiring, and I won't do it ever again. Just kidding. It was a very, very smooth process, unbelievably smooth. I was really surprised when the whole process got over in just 2 days, which is just mind-blowing. This move brought the bundle size down to just 28.5 kilobytes. This is literally less than half of before, and that is just from moving to Svelte. And the runtime performance increased drastically. Earlier, there was still slight jank in how fast the menus opened up, how the dock animation worked, but now it was all gone. Everything was super smooth. Now, let's talk a little bit about the process. Overall, moving to Svelte was a very smooth process. So, let's talk about some of the few things. Local state. This became this. Already, the boilerplate reduction begins at the most basic concept of modern web development, local state. And what about the global state? Earlier, I was using Jotai in the Preact version. The reason for choosing Jotai was how minimalistic it feels. It feels very, very close to Svelte stores compared to anything else in the React ecosystem. This is the Jotai syntax. Of course, it does not look anything like Svelte stores or state. It actually looks closer to the use state hook from React. But compared to what you get in React ecosystem, like with Redux or Context API, this is really great. This is heavenly almost. And this is a global state in Svelte. Not a lot of difference, but if you repeat it over and over in different places, it actually makes the code much smaller. Just import the store and use. That's it. No need to declare theme and set theme variables. Now, what about the styles? Styles are already plain .scss files, so all it took was inlining them into the components directly by copy pasting. And that's it. Finally, let's talk about my observations. What all I learned from this process. Svelte code is much simpler. Svelte being an extension of HTML rather than JavaScript already made it much simpler than the previous code base in JSX. All indentation was reduced by 2 levels automatically. Plus, the constructs in it like the each block, the await block, etc. all made it even more clean looking. Heck, I even tweeted it out. As you can see, the code on right looks much larger. That's because of how little code Svelte requires compared to JSX. There's also lesser number of dependencies on the code on the right. No ternaries, no CLSX for dynamic classes. Just use Svelte's features and get instantaneously beautiful code. And to top it off, some components got smaller too, some by as much as 50%, and at least 3 components were not even needed at the end. They were just merged into bigger components directly. And overall code stayed simple enough only. It was an absolute win-win. Svelte motion is on fire. macOS is an operating system, and no operating system is complete without animations. This is where Svelte's built-in motion stores and transitions come in. Svelte's motion stores are extremely lightweight and extremely powerful. They power the dock animation when you hover on it, the window close and open animations, dialog open and close animations, and using them is extremely easy. Previously, I was using Framer Motion. Framer Motion is a great library and my go-to thing for animations in Preact. But there's just one little issue with it. It's not exactly small. Motion version 4 stands at 32 kilobyte gzip. For comparison, this is nearly as much as the whole app after moving to Svelte. But of course, this is not a shade at Motion. Motion can do 1,000 things under the sun. Its size is indicative of its capabilities. There's no such thing as a good tool or a bad tool. There's only such thing as a right tool for the job. Motion was way too overqualified for my use cases. I did not need layout animations or staggered animations or any of that thing. All I needed were very simple animation primitives like entry and exit animations, spring and tween animations. That's it, nothing too fancy. And Svelte just provides this out of the box. Let's have a look at an example. When you click on any of the app icons on the dock, the icon bounces up and down. Let's compare the code for this in Framer Motion and with Svelte Motion. On the left, you have the code in Framer Motion, and on the right, it's the Svelte Motion code. Clearly, Framer Motion one looks much smaller, but let's read both of them once. Here we have an object animate of obj that contains the CSS properties to be manipulated. Hence, we have translate y as an array here. The array contains the keyframes. Right now, it's all 0 to indicate to not animate initially. Next up, we have an event listener on the span. So whenever you click or tap on it, it will trigger the animation. The keyframe becomes 0% initially, then it reaches minus 39.2% and then returns to 0% again. This makes the app icon bounce. Next up, don't let the animation run on component mount. Pass the animate obj to the motion components to let it know what to animate. In this case, it's only the translate y property. Next up, defining the animation type. I want this to be a spring animation and this should go on for 700 milliseconds. Easy. And finally, transform template to make sure the transform 3D is not applied, which is what Framer Motion does by default. First up, defining a tweened store. Because I want to control the duration of the animation, it's a tweened and not a spring. However, to give it a natural feel, it uses sign in-out easing. Next up, we have got the button, which on click will trigger the animation. This is a span that will actually be animated and transformed. You can see the transform style applied to it. And coming back to the actual animation implementation, the open app function. This is what actually handles the bounce animation. And if you see the bounce animation, technically, it's just 2 lines. Line number 11, we tell it to change the value to minus 39.2. Notice the await keyword. We are waiting for the animation to finish before we move on. And when the animation to go above is finished, we move on to the next part, which is bringing it down. And that is simply setting it to 0. Notice how intuitive this version is. It legit reads like this. Go up to minus 39.2, and when you are done with that, come back down. As simple as that. It's easy to scan and make sense of. Framer Motion 1 is smaller, but if I wanted to make the animation more bouncy or extreme, I would have to search a lot of Framer Motion docs to figure out how to do. Whereas in Svelte 1, I would be confident changing it. Transitions in Svelte are basically animations to be run when some DOM is created or destroyed. This is nearly impossible to do in Preact without relying on external libraries like Framer Motion. But hey, in Svelte, this is built in and extremely easy to do. So of course, I put transitions in everywhere I could. Earlier, when you opened / closed any app, there was no transition. Now, when you close the window, it collapses into itself while closing, giving an awesome transition. This little piece of code allows the window to close with a transition. I added this animation when I moved to Svelte version because the React version with Framer Motion just felt too complex, so I did not even bother with it. And this is what you get. Looks good for just 13 lines of code, right? And remember, I showed you the package.json that the React version had. This is the Preact version, and this is the latest one with Svelte. This is 2.75 times smaller. But let me blow your mind even more. That dependency you see at the bottom, I created it. A month before I did the transition from React to Svelte. I created it as a fun exercise because Svelte ecosystem did not have a tiny draggable library with the features I wanted. and it is just 2 kilobytes in size. So because it's a home cooked library and very small, I'm just going to remove it from the comparison. And that implies that the number of dependencies is now actually 3.67 times smaller only. And no, this isn't because I repurposed the app logic to not use the dependencies. It's that most of this stuff is already built into Svelte. I didn't do a lot of work. It just happened. So in the end, this brings us down to the final bundle size comparison. From 146 kilobytes to 28.5 KB, this led to a reduction of more than 5 times in bundle size. But hey, that's not even the most important part. Initially, bundle size and performance were the things I always gave the highest priority. Not anymore. Now it's the readability and simplicity aspect that I value the most. Svelte gives me a lot of confidence. If I ever want to add something to it, I'll be able to do so very confidently. The code is very readable and simple. Final words. Really, moving to Svelte made me realize how extremely powerful it is. A lot of React developers treat Svelte as a toy, and I can't blame them. I was one of them once. But really, it isn't a toy. In fact, I'd say it's more powerful than React. Yes, less control over everything than React, but it is a better choice for 95% of developers than React, in my opinion. Thank you.
Hey, that was a great talk. I know you were worried about the fan noises, Puru, but that wasn't an issue thanks to Brady and his magical sound engineering skills. All right, so from 146 kilobyte to 28, that's pretty cool. I'm definitely going to have to take a look at the repo as well. All right, so next up we have a talk by Matthias Stahl, and it's about data visualizations at Der Spiegel, the German newspaper. So let's take a look at that.
Hello everyone, I am Matthias and I am a data visualization designer. I work for the German news magazine Der Spiegel, which is one of the largest newspapers here in Germany. And today I want to show you how we use Svelte for data visualization. So why do we use it? And also a little bit look behind the scenes how we use Svelte, especially together with D3. At Der Spiegel in Hamburg, Germany, we have a graphics desk with around 20 people working in graphics, working in design. We also have developers and editors. And we all love the combination of Der Spiegel and Svelte. Well, they also have quite similar logos, as you can see here. And let me show you why we use Svelte. But let me first start to show you which types of visualization we usually produce in the newsroom. Because in the world of data visualization, I think that visualizations for the newsroom are a little bit special. There could be really simple graphics and charts like that one here. They could be static also like that one, which is a little bit more customized. Here you can see a map of sunken ships at the German and Danish coast. And there are graphics that might be interactive pieces that might be a little bit more complex, like this tracker of the German government or of the popularity of the German government, where you can click, hover, and get more information by exploring the visualization. And for all these different types, these different levels of complexity, we have 3 special requirements in the newsroom. Speed is the first one, so we need to be very fast as the news cycle goes very quickly. We also need to be very accurate because we are read by so many people, and we are even read by, let's say, politicians or other decision makers. So it's really important that everything that we publish is really accurate. And then there's originality as a third requirement. So we want that our readers can see, okay, this chart, this interactive piece, this is now from Der Spiegel. So this is something that we produced. So I think these 3 different requirements are really important when you do data visualization for the newsroom. And especially for the more complex and interactive pieces that we build, we found that Svelte, in the lovely combination with the 3, is really the way to go, is really also the easiest and most effective way to go. But before I show you why, I want to recapitulate a little bit what is different between Svelte and D3. And especially I want to show you the things that Svelte and D3 respectively are really good in. So Svelte is, of course, really cool for everything which is DOM manipulation. So when you want to change the DOM, when you want to be reactive to user inputs, to data, to whatever, then Svelte is made for it. Just think of the $sign and the reactive statements in Svelte. So this is really easy. Interestingly, you can also do that with D3. There is the select function, for example, where you then also can bind data to different DOM elements, and then you can make the DOM elements react to the data and so on, but it's quite cumbersome in D3. So Svelte is better for that. Also, Svelte has all the batteries for really great transitions. They might be CSS based, they might be JavaScript based, it doesn't matter. Svelte comes built in with all these tools that you need for good transitions, and a couple of transitions are already built in. And then there's everything about the user interface, you can say. So when you build up your app, when you design a simple button, a navigation bar, you can have your Svelte component for that, and you can put it in a toolbox and you can take it whenever you need. So Svelte is really good to build up your user interface. On the other hand, D3, of course, also has its advantages. So D3 is always good for the math and the paths. So when you want to calculate something, it could be scales where you transform from your data coordinate system to the pixel coordinate system of your user screens, or it could be more complex operations if you think, for example, of map projections. And then there's the paths, as you might know. The basis for many data visualizations on the web is SVG, Scalable Vector Graphics. And one of the most flexible, if not the most flexible element in SVG is the path element. And D3 comes with a lot of functions that make it really easy to work with the paths and to calculate the attributes for the paths, for example. And lastly, I would also say D3 is really cool when it comes to transformations. This could be just number format transformations or date format transformations, things like that. And there's also a big difference between Svelte and D3 when it comes to the actual coding style. So Svelte has a really declarative style. So when you code Svelte, you really write HTML and you really describe how your app is looking like in the browser. If you see Svelte code, you can easily imagine how a website, how an application looks like. On the other hand, D3 has an imperative coding style. So that means you say, do this, do this, do this, and in the end, your browser will produce the finalized image or graphic. And that means it is much harder to read D3 code and to immediately understand how the result will look like. So I would see it like that. Use Svelte as a basis to build up everything, and then see D3 as just another function library that you can import into the Svelte world. And then you just use the function that you need. So I today would recommend do not learn D3 on its own if you want to do data visualizations. Immediately learn it together with Svelte from the beginning on. Now, I have talked a lot about the theory behind our data visualizations and many data visualizations in newsrooms around the world. Now let's come and look a little bit behind the scenes. And I have selected today one example, which is about the Nobel laureates that we had since 1901. And let me change for that to my browser, where I opened the interactive piece that we produced. So when the Nobel Prizes were announced last year, we thought, well, it might be nice to just show who the current Nobel Prize winners will be in December last year. And we decided to build up a scrolly telling piece, which means that you have a background where all the visualization happens, and in the foreground you have these moving content boxes that are little explainers for the things that happen in the visualization behind. And we start with the 2021 Nobel Prize winners, and yeah, we had a focus on the German ones, of course. So we were able to highlight some of those here. And this whole application, so everything that you see here under this red bar of the Spiegel website, is really made with Svelte and D3. And now, when we explained the current Nobel Prize winners, we show them in the context of all Nobel Prize winners that we had since 1901. And here by color, you can see the different prize categories like physiology or medicine, physics, chemistry, and so on. And now we do a little, well, statistical analysis. So we just use now the different shapes and aggregations and clusters to dive into this data set. So here we can see that there are a lot of prize winners for physiology or medicine, but not so many for economics. This is quite natural. And then when we go a little bit more down, we can see that we are able now to highlight prize winners that got the prize more than once. And then, of course, we can go to different arrangements, like also, for example, how many women were there, how many men, and you can see like the imbalance. And then we highlight again this year's Nobel Prize winners. And then, of course, we do not have to stick to these like circular clusters here, but we can also do like histograms here. This is now the age distribution, or we can split up the histogram again by prize category and can learn, okay, for the Nobel Peace Prize, there is really some Nobel laureates that were really, really young. And of course, we can highlight again and again people, and then go back from the histogram view, for example, to another circular cluster view where we highlight some countries until the end, where we go back to the initial cluster where we show Nobel Prize winners that were born in Germany. So this whole application was built with Svelte, and it needed to be built very quickly. We also have a certain style for visualizations at Der Spiegel that you can hopefully see here a little bit. And of course, it also needed to be very accurate. So this is data driven, of course, in the end. And all these three requirements can be achieved by using Svelte. So I said it will be a look behind the scenes. So this is now just behind the paywall, but now let's go back behind the real scenes. And let's just go to my code editor where I already opened this project. And what you can see here first is that I love to use as many components as I can. So for everything like histogram axis, everything that can be separated a little bit from the rest, I tend to use components. And this is a good idea because from there you can build up then component libraries. And that makes it really easy to reuse components in the future. And this is what we do all the time. And this is important to be quick and to get some originality because your button looks then the same every time. And this is what we want to have, at least in our company. But I want to focus now on one component here, which is the laureates component, which is basically the whole background component where all the Nobel laureates are shown. So these little circles that you've seen in my browser before. And here within that component, you can see that there is first a canvas component. And you can see that this is not an HTML canvas here. It's really a Svelte component. You see the capital C here in the beginning. And I'll tell you a little bit more in a second about that. But what you also can see that within the canvas here, I have an each block on my rendered data, and the rendered data is just all the Nobel laureates with like their X and Y positions where they should be positioned, because I calculated somewhere else these different layouts and then say, okay, which chapter are we in? Okay, now laureate A needs to be at position X, Y, and so on and so on. And so we can just render over the whole data set. And for each laureate data point, we can actually draw one laureate. And this happens in the laureate Svelte component again. And here you can see that we also love the idea of encapsulated data. So this laureate component only needs to know its X position, its Y position. It also needs like a radius, a color, so some stuff for the appearance. There might be also an image. And then also like, is it highlighted? Is it in the background? Is it shown or moved with some delay, and so on. So this is just the information this laureate component needs to know, nothing else. And then this is what you've seen before. Everything is embedded in this canvas component, because here for this special visualization, we cannot rely on SVG as the technology to really draw these circles. It would be possible, however, with so many circles, all the transitions that we would have between the chapters, they wouldn't be so fluid, so effective as they are right now. So here we have to use Canvas. And I hear a lot of people, and also me 3-4 years ago, saying, oh my, when you use Canvas now, then it's really going into an imperative coding style, because the Canvas API works a little bit like D3. You have to tell it, do this, do this, do this, draw a circle, draw this, but you cannot really outline your complete build-up of the app in a declarative style. And I want to do that because we work in small teams that change all the time, and I want my colleagues that they can easily read my code. And for that, I want to be very declarative, and this is why I use this trick, that I have this special canvas component here. And on this canvas component, I can just loop over my laureates and draw them. So, but how does this work? So I would say that we start the other way around and look first into the laureate component here. So one of these laureate components looking like that. And let me just give you a complete overview. So you can see a lot of JavaScript code, like here in the beginning, you can see, okay, here's my X and Y position coming in. That's really where this laureate circle is drawn on the screen. Then you can already see here is the get context function from Svelte. So it grabs variables from the parent element, which is the canvas here. This register, deregister, and invalidate. Those are 3 different functions. Then there's a lot of other stuff. Then very central, we have this draw function. This is really interesting. Let me come back to that in a second. We have some Svelte lifecycle functions and more JavaScript. And that's surprising. There is no HTML and no CSS in this component. And this is what we call renderless components. And if you want to know more about them, I will show you a little bit how they work here in this example. But I would also recommend to watch the videos of Li Hao. He's a really good explainer when it comes to that. And I learned also how to do that by his videos, which is really cool how he does that. And but now let us go back to this draw function that I marked here already, because the draw function, as its name says, it draws the circle, and the draw function gets the CTX, which is the context of the canvas. We have right now no idea where this context is coming from. And then you can see here in the first line, it translates the pen basically to draw to the X and Y positions. And I will show you later why it is not directly X and Y and why we have these dollar signs here. And then here in this part, the actual circle is drawn. And then there's just a little bit more design. If there's an image, we draw also an image and so on. But well, the draw function is defined here. We have no idea where this context is coming from. And let us have a look how that works. Here in the lifecycle functions, we can see that on mount, we call the register function that we get from the context, from the parent, which is the canvas component. So the canvas component is giving us this register function, and we call it with the draw function as an argument. And then we also immediately call invalidate. We have no idea why we do that, but for sure, when this component, when this laureate is disappearing, then the deregister function is called again with the draw function as an argument. A lot of question marks, I would say. What's happening here? We register somewhat this draw function. Interesting. But then there's some other stuff. There's also this after update. It's just one line, but it's like the centerpiece of this whole component, I would say, which means every time this component is updating, then call the invalidate function. The invalidate function, again, is a function that we get from the parent component, from the canvas component. We still have no idea what it is doing. And I think now is the time to have a look into the canvas component. So let's go to the canvas component. The canvas component is looking now again a little bit different. This is I would say, quite normal component. We have like width and a height that could be set. There is an update function, which is interesting in a minute. And there is also here set context, which is interesting because now we can see, here's the place where this register, deregister, invalidate functions are defined. Cool to know. And here we can see, okay, register takes an argument, which is just called fn function here, which could be the draw function. You remember, and we put our draw function from each of the laureates into this draw functions array. And the other way around, when we deregister, we cut out our draw function from the draw functions array. And then there's also invalidate, and invalidate is really interesting because invalidate has this line here, which means we do a request animation frame whenever invalidate is called, and we execute the update function. Okay, update function, you remember, we just saw the update function here on top. It's that one. So the update function works with the context. We still do not know where the context is coming from. The context is a part of the canvas. It's the access to the canvas. And there's just some simple lines here, which just cleans the canvas whenever something is updated. And then it gets interesting because now we go to our draw functions array. We iterate through this array and we call each draw function with the context. And now we know, okay, here's the context coming from. And the context, where is the context coming from? Defined here, it's coming from canvas. And canvas itself is in our HTML part here, a real HTML element. This is the canvas element. It's bound to the canvas JavaScript variable. And additionally, we have this slot here, which means, okay, this component here can take children, even though a canvas, an HTML canvas, cannot take any children. But here with this Svelte component trick, we make the canvas taking children, at least virtually. Okay, so we've seen now that the register function brings our draw function from each of the Nobel laureates into the draw functions array. And all the draw functions in the array are executed when invalidate is executed. Okay, and we remember now when I go back to laureate.svelte, this invalidate function is called whenever there is an update. So that means if I give new XY coordinates to one of the laureates, then I get an update. Okay, then my canvas is newly drawn. Well, that's cool because now I just need to send new data to my laureate component and encapsulate it. And I do not have to worry about the canvas at all. It will just update automatically because of this registration of the draw function. That's quite cool, but that's not enough because now we could say, okay, now I'm still in the laureate component, and well, renderless components for using canvas is really, really cool, and would be, for me, it would be a sufficient reason to say, okay, I go for Svelte now all the way for all the visualizations, but there's even more. I told you of transitions, for example. So if you remember in the draw function here, we draw our circle not to the XY coordinate, but we drew it to this $tx, $ty, and those are stores. And those are tween stores. So let's just have a look where tx and ty are defined. You can see that here. It's just by calling the tweened function, and we set in some tween parameters, like how long should the transition be, because the cool thing about the tween store is it has a value. That's the value you set. And when you change the value, the difference between the old and the new value is animated, or there is a natural transition over time. And this is exactly what happens here. So sorry when I jump again a little bit to the bottom, but exactly here, when X or Y changes, TX and TY is updated and animated. And I read this animated value in the draw function by $tx, $ty. And every time a little frame of this transition happens, the after update function here is called, because the component has intrinsically updated. Invalidate is called as subsequently, and that means that I do not have to worry about showing this transition on the canvas at all. So there is tweened, which is cool as such, and then it can be coupled to this whole renderless component system to build up a complex visualization in a declarative coding style with renderless components on canvas. So now you've seen how such a visualization system could work. And now you might wonder, well, he has talked about Svelte loves D3. And yeah, maybe you've seen it, but we came across a little bit of D3 here as well. There is more in, but I just show you a little highlight. If I go back to the laureate component, you remember this was the component for each of the single circles. Then we draw these circles here, and to draw the circles, I use this pi generator, which uses this pi function. So that is just a path generator, which produces the path for the circles of the Nobel laureates. And this pi function here really is something that we get from D3. And this is exactly what I mean. You build up the whole application, the whole user interface or everything which is reactive DOM manipulation and so. And then you look, okay, now I need, for example, this circle. And then you go to your D3 library and just take out what you need. And this could be just this simple pi generator function here, or it could be scales and. So there is much more. And this is, I think, how data visualizations can be built in a really, really effective way. So these are the Nobel Prize winners since 1901. And if I go back to the three main requirements that we have in the newsroom for data visualizations, you can maybe see how Svelte helps us to achieve them. So we could just import any other JavaScript library, let it be D3, let it be like something like Flubber or something else. What you need in visualization, you could just import it and use the functions that you need, nothing else, because you remember Svelte is there for all the DOM manipulation stuff. And for everything else, which is more complex, which is more specific, you just pull in your library from outside. Then the whole thing about concept abstractions. I just showed you one example with the renderless components to use or to build up a Canvas component that can take children so that you can use the Canvas API in a declarative manner. That's really cool. Then with the whole component, with the stores, so that you can like separate data manipulation stuff to stores, for example. You can build up component libraries. You can even build up store libraries. So we at our company, we have like a toolbox of different components that we could reuse all the time. We have a toolbox of stores that we could reuse. We also have a toolbox of transitions and actions and so on. And that's really cool. And that helps, of course, to have a high speed during development, but also to be accurate because you reuse components that were tested. And then the whole hierarchical concept about the components is not only valid for the components, but also for the data concept behind. So you have your data for an application, but single parts of the application do only need to know parts of the data as well, like the laureate component, which just needs to know its X, Y position and some stuff to like the color and opacity and things like that for the appearance. So here, Svelte is a really, really great help. And with that, I want to encourage you to go to github.com/spiegelgraphics, where we try since recently just to publish code from our more complex visualizations. And you can also go to my personal website, hicks.com, where you find also other larger visualization projects, mostly together with the GitHub link to go into the code base. And with that, I want to say thank you very much for your attention. And I hope you had a little bit of fun and learned a little bit. And yeah, I would say have a nice day and see you soon. Bye.
That was awesome. All of the talks are awesome. I don't know why. It must be Svelte, right? Anyway, so you should check out Matthias's work. I've posted a couple of links in the chat, and yeah. So now we're going to go for a break for about 25 minutes, and we'll be back at sharp. So that's 6 p.m. here, but I'm not sure where you are. So yeah, just be back in around 25 minutes. So we're back. I hope everyone managed to grab some food, some drinks, and ready to talk to each other, because we're going to head off into the meatball sessions. So meatball is a service where you get paired one-on-one with someone. You need a camera and a microphone. Hello, is that better? All right, so you guys can hear me now. All right, perfect. Sorry about that. I guess I turn into a robot sometimes. So anyway, welcome back, everyone. We're gonna head into the meatball sessions in just a minute or so. But before that, I'm gonna explain how it all works. So meatball is a service where you get paired up one-on-one with someone else that goes to the link that we provided. So that's sveltesummit.com/meatball. And you need a camera and a microphone, and it only works on desktop, unfortunately. So yeah, there's that. But I'm going to let Josefine explain more about that. So here we go.
Next up, we have the meatball session. This is where you get to talk to other conference attendees all around the world in real time and face-to-face. You can talk about Svelte, all the talks that we've just seen, or just get to know each other. Before we get started, I just quickly want to tell you a little bit about Storyblock. So we are a software as a service company providing a solution to the content problem in form of a headless CMS. Our founders were basically fed up with the existing CMS solutions they were working with and developing for clients in their jobs at an agency, and aimed to create a headless CMS that gives both editors and marketeers, as well as developers, a good user experience. We're completely technology agnostic, so you can work with any framework that you like, structure the project as you need it, and use any API of your choice. In other words, there's a lot of freedom. Speaking of freedom, we're also a fully remote company. So regardless of where you are located, if you're looking for a new position, feel free to reach out to me or directly to our recruiting team. We're looking to grow a lot this year, so there are many open positions. But that's already all about Storyblock. Let's get started with the meatball. You can join via the link in the chat or simply go to sveltesummit.com/meatball, and that's meat with 2 E. Enjoy.
All right, so let's head into the meatball session. right. I hope you guys had a lot of fun at the meatball session. Sorry for the abrupt ending. It's probably something we have to fix for the future there. I'm gonna ask my friend to implement something to solve that abrupt thing. I got to talk to a bunch of different people, and it was a lot of fun. So yeah, let's move on to the sessions then. So next up, we're going to take a look at some motions, specifically Svelte in motion. So this is Penguin's talk, and yeah, let's give it up for Penguin.
Hey folks, today we're going to be putting Svelte in motion. More specifically, we're going to take a look at a few examples of high quality motion in native applications and see what it might look like to implement those for the web in Svelte. So this talk's going to take a simple format. I've built a relatively straightforward application. I'm going to gradually add motion to it to improve the user experience, taking the lead from some of these high quality native applications. But first, I think it'd be useful to take a look at an example of this kind of motion. What do we mean by native-like transitions or native app-like transitions? What does that actually mean? And what are the key characteristics of high-quality motion in native apps? I've got an example here, and this is the Apple Music app. And I think this app has some really nice examples of the kinds of animations that I'm talking about. When we actually look at apps like this, it's really hard to pin down like what it is that makes them feel the way they feel. And I think, a lot of it's just to do with polish and refinement, but I think there are a couple of characteristics that are really, really important to this kind of an experience. So the first one is just responsiveness. When you touch the screen, something happens almost immediately. The latency is really, really low, and it feels like you're actually controlling the elements on the page. And I think that's a really important characteristic. The other thing is performance. These animations are really smooth. They perform very, very well, and I think that is definitely a key characteristic of this kind of thing, is just having really good on-device performance. And I think the final thing is just attention to detail. They're just very refined, and often there's more going on than meets the eye. There's actually often kind of multiple animations happening at the same time that gives that kind of natural feel. But I just think there's an attention to detail with the interaction design in native apps that is frequently not present with similar uses of motion on the web. So that's kind of like what we're talking about when we talk about native animation. We're really talking about responsiveness. We're talking about performance. And we're talking about how natural we can make things feel. So having like lots of attention to detail, making sure the animations feel really good when you're interacting with the page. So now we're gonna take this example pretty much, and certainly an example inspired by this, and we're going to start adding little bits of motion, but for the web. So this is our little application that we've got. It's just a simple viewer for some animal images. So at the top here, we've got some animal categories. We can click through to see the individual images for that category. And if we come back down, we can see we've got the individual images in these little horizontal scrollers as well. A couple of horizontal scrolls here. It's quite a nice pattern on mobile. It's quite easy to interact with. It's not as good a pattern on desktop. And we're just going to add a little bit of motion just to make the UX a little bit nicer. So the first thing that we're going to do is add some scroll snapping to these carousels. So when you kind of scroll through, it's really easy to kind of end up with like half on, half off screen, or find yourself centered in the middle somewhere or something like that. And it'd be nice if when someone scrolled, it just automatically kind of snapped to see an actual image, because otherwise we're going to have to correct this behavior. So you scroll once, and then you're going to need to actually refine that scroll position. We can make this simpler for the user. So in order to do this, all we need to do is add a couple of CSS properties. There's no JavaScript, there's no dependencies required. It's a super simple technique. So we dive into categories. So this is the container, this is the scroll container. And we just add scroll snap type here, and we're going to add the axis, which is X, and mandatory. Now, this won't actually do anything because we need a companion CSS property on the direct children of this scroll container as well. So we can jump into category here. We can see that box is the child, so we can go down to box, and we can add scroll, snap, align, and set that to start. And you can see it jumped slightly there, but we can now see we've got nice snapping scroll. What's nice about this is it kind of respects default scroll behavior. So if you scroll very heavily, it will still scroll past multiple items, but it always snaps. And in a quite gentle way, in a quite subtle way, making use of native platform features like this means that a lot of the implementation is solved for you. It'd be nice to get the same thing on here. It works really nicely with multiple elements as well. So we just need to go into this animal. So this animal component contains a list of all of our items. And so again, container is the container. So we can go here and we can do scroll snap type, again, X mandatory, save that. And this box is our child of the scroll container. So we'll go and find box. And we'll do scroll snap align start, and we can see it snapped into view. And this is really, really nice as well. So it will always kind of end up with one of these items aligned, no matter how hard or softly we scroll. And it works on all of them, of course, because we're using components. And that's a really, really simple feature that you can implement pretty much anywhere that you're using a horizontal scroller. It's very common to see carousels where you have to do a swipe action that doesn't actually have any responsiveness. So the actual scroll won't move until the swipe has been kind of detected and confirmed, and then it will animate. Whereas this just makes it feel much, much more responsive. And when we were talking earlier about making sure that our interactions are responsive, this is the kind of thing. When you do a thing, something should happen on the screen. So it feels like you're in control of the gesture. And then you can kind of pick up and finish off the animation. And that's exactly what this does with just 2 lines of CSS. The next thing I'd like to add is some page transitions. So we're snapping into here like this, but realistically it would be really nice if we had some kind of a transition when this happened. So it felt like some kind of state was changing on the page. So we're going to use Svelte's built-in transitions for this, and it's going to be a really simple implementation. So we're going to dive into this detail. So if we go into index, actually, we can see that we're importing detail here. And, when the page variable changes to detail, I'm not using routing in this case, it renders the detail and it kind of unrenders this. So we're going to jump into detail. I'm going to do something really, really simple. So we're going to import from Svelte transition, and we're going to get fly. And we're just going to apply this fly here. So on this box here, we are going to add the transition, and the transition we're going to use is fly. And we're going to pass some custom parameters. So what we're going to pass here is we're going to pass an X value of 500. So fly is going to fly something into the screen. By default, it will also animate the opacity. So we're going to set the opacity to 1 to make sure it kind of stays on screen at all times. And we're going to set the duration to 250. Now, if we click here, we can see that this is now kind of animating in quite nicely. However, it is still a little bit janky. So in order to make this feel really nice, we're actually going to animate the screen behind it as well. So we're going to jump into the index to do this. And we're going to do pretty much the same thing. So I think we'll do it up here. We will same import. And we will do much the same thing here. So we're going to come down here. We're going to add a transition of fly. And we're going to set, in this case, we're going to set the Y to 0. We're going to set the X to minus 150. We are going to change the opacity, but we're not going to make it go down to 0. We're just going to kind of like fade it slightly so it feels like a nice transition. And again, we'll set the duration to 250. 50. Now you'll notice here that we haven't got the same kind of X value as we have on the thing that's animating in. So obviously the thing that's animating in is totally off screen to totally on screen, but we're not actually animating the home page as it animates out totally off screen. We're actually just animating it a small amount, and it almost gives this kind of like feeling of distance and it feels just that little bit slicker. And it's kind of little kind of tricks like this that make things feel, you know, nice when you're kind of like animating them. And it's also kind of, again, cancelable. So we spoke about this earlier as well, about how animations need to be very responsive, but you need to be able to say, well, actually, what if I decide halfway through a gesture or through an action I want to get rid of it? Can I easily reverse my decision? And this is a good example of being able to do that. And this is, again, another little thing that just makes it feel that a little bit more refined, that little bit more polished, and kind of helps the user to understand that, you know, different levels, different hierarchies of the site can have slightly different page transitions. It can almost act like a visual language for navigation. So the final feature I'd like to add to this is the ability to preview these images. So instead of just having these little images, I like to be able to click on one of the images and have them kind of scale up so that we can actually preview it. And I think I'll also add a background overlay, so it kind of acts like a little light box. This is the most complex animation we're going to implement. And it's mostly complex, not because the animation itself is complex, but because there's a bunch of kind of things we need to take into account. So we're going to use springs for this instead of tweens. So Svelte ships with two different animations, springs and tweens. And a spring is a type of animation that tries to emulate spring physics, so it generally feels quite natural. One of the benefits of a spring is that it's consistent no matter what values you're animating. So if you've got an animation that takes 500 milliseconds, if you only need to travel 10 pixels, that's going to have a very different speed than if you're going to travel 100 pixels over the same duration. Whereas springs don't have a duration. They finish when they're finished based on some kind of model of physics. They also have the benefit of feeling more natural without you needing to find the right easing. They're not always the right choice, but they are really, really nice for UI interactions and UI animations. So we're going to import the spring here. Apologies for my terrible typing. And in order to implement this, we need to track a few things. So we need to track, first and foremost, the window width or the box width that we've got on the screen here. This is going to be a number. We'll default that to 0. We're going to track the height as well. We'll also default that to 0. And now we actually need to keep track of a number of things here. So we're going to create a new interface. I'm going to call it active. And this is essentially an object that's going to contain the index, the left value, which is a number, the top value, which is a number, and the origin, which is actually a string. This is going to be important as we progress through this example. So we're going to actually we're going to create this. We're going to create some default values. So our index is going to start with a -1 value. Left will be 0. These are wrong. Top will be 0. And our origin will be 0, 0. We're also going to instantiate a variable called overlay to decide when we should show or hide the overlay. We're going to default that to false. And we are going to instantiate a couple of springs. So we're going to have two springs here, one for the scale and one for the opacity. The scale is going to be the scale of the image itself. And the opacity is going to be the opacity of the overlay. So the overlay is actually going to be on the screen at all times. We're actually going to use that to measure the size of the screen. In this instance, we can't actually use the window width, because if we were to make this kind of bigger than, I think, 500 pixels, it would actually kind of end up with a wrapping box that keeps it all in kind of a mobile view. So we can't actually use the window width, although you might be able to do that in a real situation. On the opacity, we're also going to kind of modify these spring values. We're going to set the stiffness to 0.2. And you can change just how bouncy and how stiff the actual spring is by modifying some of the options. So we've got a little bit of kind of state set up now. And what we essentially need to do is we need to track the actual position of this item on the screen. Because we're going to scale it up and it's going to come outside of its containing box, we need to prevent it from clipping, because if we were to scale this, say, by kind of like 2 times, it would kind of come down here somewhere. But the bottom part of it would actually be clipped. So what we're actually going to do is we're actually going to convert this, when it gets selected, to position fixed, so that it's not kind of impacted by its containers. But when we do that, we need to know what the actual position of this item is on the screen, so that we can set that explicitly so it doesn't jump around. And that's why we're tracking this. We're tracking the origin, because depending on how close it is to the edge of the screen, and indeed this edge of the screen, we need to set the origin in a different direction, because we want this to scale kind of top left to bottom right in this kind of a position. But for this image, it needs to go kind of like top right to top left, you know, and so on and so forth, depending on the positions. And of course, we can scroll them, so it needs to be dynamic. That's why we're tracking these, and we're going to calculate these values when we click. So the next thing we need to add is the overlay. So the overlay is just going to be a div. And we're going to add a class to this. And we'll add some CSS to that in a moment. We're going to add a click handler to this, and we're actually going to bind clear to this click handler, which will populate the body of that in a moment. We want to set the style here to the opacity value of this spring. So we're actually using this, we're using the $sign syntax because we want the value from the spring. The spring is just a store. And we're actually going to use this. This div is going to be kind of 100% like high and wide. So we're actually going to use this to find out like what the height and width of the screen is. So height is going to be WH and width is going to be WW, which is the variables that we've set here at the top. So now we've got this, we're just going to add a little bit of CSS. It's just a copy paste job. There's nothing particularly interesting about this. It's position fixed. It's got a very high Z index. It's set slightly bigger than the screen to prevent any kind of clipping. It's got a background color of black. And the pointer events are set to none. So this is quite an important one. What we're actually going to do is we're going to go here. Actually, we can use this syntax. We use this nice new syntax here for this. And we're going to add one more kind of style property. And that's the pointer events. So we don't want this to interfere with the page in any way until the overlay is active, at which point clicking that we want it to actually clear what's present. So we're actually going to set this to overlay. Then we'll do auto. Otherwise we'll do none. I've set the opacity to 1. So I'll change that to 0. And as we can see, you know, this nothing interferes with the screen. It's absolutely fine. And we don't need to worry about it. But when we click, we want stuff to happen. So What we're going to do essentially is when the image tag matches, when the specific image tag that we're iterating over matches a certain condition, we want to change some of the values. So what we're actually going to do this in line here on the element itself. I'm going to add a bunch of style properties based on, the states. Basically, is this the selected item? If so, these are the changes that we want to make. So we're going to set quite a lot here. So the first thing we're going to do is style the position. So if active.el.index is equal to I, and this is going to be the basis for pretty much everything, then we want to set this to fixed. Otherwise, we want it to be static, which is the default kind of thing. I'm actually going to copy paste this conditional here because we're going to use it quite a bit. Again, style. This time it's going to be left. And we're going to do the same thing here. And if it is the same one, we're going to set the active el.left. Otherwise, we're just going to set it to 0. We're going to do the same thing pretty much with top. We can find active el.top. Otherwise, 0. This is a really important one, so we're going to do style transform origin here. Again, it's going to be the same thing. We'll calculate the transform origin in just a moment. We'll set this to origin. Otherwise, we'll just set this to 0, 0. We're also going to modify the transform value. So this is very important. So if the style, not what I had in mind. So style transform. I'm actually going to do quotes here. So what we're going to do here is we're going to set the scale. So we're going to do scale. And now inside of this scale, we're going to do if it is matching the index. Then we are going to set it to scale. Otherwise, we're just going to set it to 1. And scale is always a numerical value anyway, so that's fine. And now we're going to do something kind of, I guess, maybe slightly controversial, but I'm going to set the pointer events here as well. I just want to be able to click through this, basically, when it's the active image, because it will allow us to trigger the click on our other thing, on our overlay instead. So we're going to do this. Just make sure we've got our overlay as well. This just means that essentially if the image is big, we'll be able to click through it, and then the overlay will pick up our click instead. It's not really an ideal implementation, but it's a quick and dirty one that gets the job done. And the last one is the Z index. So style Z index, and it's the same story. We'll just set this to we can set this as a number. So that's what we've got so far. Now, we're still not nothing's happening still. But we can now start implementing our actual handle click. And this is where we're actually going to populate this active EL with the correct values. So the first thing that we're going to do is we're just going to check to make sure that we're already passing in the index here. So we're just going to check to make sure that we've actually got a reference. And I'll just check if it's equal to null. And we'll just return. I could just do this instead. It's a bit simpler. So that works fine. So what we need to do here, it's a little bit more complicated than just getting kind of like the top and the left properties, because we actually have some margins to deal with. So we need to get the offset. So what we're going to do is we're going to create a new variable styles, and we're going to do window.getComputedStyle. I'm going to pass in the element, this specific element that we're tracking, like this. And now we can get the offset. So we'll get the top offset. I'm going to do this by, we're going to need to parse int this so we can get a number from it. And then we're going to do styles. Not that. It's style. Let's change it to styles, actually. I'm going to get property value. I'm going to get the margin top for this one. That's a string. I'm going to copy this, and we're basically going to do the same thing here. We're going to get the left offset. I'm going to get the margin left, like so. So we're going to need those values in a moment. So the next thing we're going to do is we're actually going to, let me make this bigger. We're actually going to get the bounding box for the element itself. So we're going to do, we're going to deconstruct this. We're going to want the left. We're going to want the right, the top, the bottom, and we're also going to want the width. And this is going to be eli dot get bounding client rect. And now we can actually use this. So the most important calculation that we need to perform here is we need to decide which way we animate this. Is it, top left to bottom right to bottom left to top right, or bottom right to top left? And we're going to do that by calculating the distance, essentially, or the difference between the left and the left and the right and the right. So what we want to say is, say we're animating this penguin here. We want to say, is this area greater than this area? And likewise, when we're animating this one, it's like, which are we closest to, is all we're saying. And we can do that by just saying kind of like, which of these calculations is closer. It's actually quite a simple one once you kind of can get your head around the box stuff. And we're going to create an array because we need to track the kind of the left and right, but we need to essentially do the same thing at the top and the bottom as well. See, like, what am I closest to, or what am I furthest from? And so we're going to do this by creating a new variable, let pause like this. And we're going to make it equal to an array. And in this array, we're basically going to compare the left value, which is here. And that's going to give us this distance, but we need this distance. So we need to compare like the width of the box to the right value. So we're going to do this by kind of like, is the left, which is just already calculated for us, less than the window width minus the right position. So that's this minus this, and that's going to give us this value here. And we're going to just transform origins are in kind of percent values if you want. So we're actually going to do percentages like this. So that's going to give us the kind of, left and right. What about top or bottom? So we're essentially going to do the same thing. We're just going to compare the top, which is already calculated for us, because the top will be the distance between this and this. But now we need this distance as well. So that's going to be the height minus the bottom position. So we're going to just do WH minus, WH minus the bottom. And it's the same thing again, 0 and 100. So this is going to give us our transform origin positions. Now all we need to do really is just take all of these calculations and figure out what we need to set things to. So we're changing these to position fixed. So that means we need to set the left and right values to the right value so that it actually kind of ends up in the same location. So it looks like a smooth transition, but we're actually kind of changing some important values. I'm going to do that by taking the left value and subtracting the offset, because that's going to help us to take into account any margins that have been applied. So first and foremost, we'll set the active el.index to the index that's being passed in. This will cause all of those styles that we applied before to actually trigger. The next thing we're going to do is we're going to set the active el.left. And we're going to set this to left minus the left offset. And this is going to be a pixel value. So we're going to do pixels. We're going to do the same thing with the top. This is going to be top minus the top offset in pixels again. What have I done? There we go. We'll save that and I'll get some semicolons for us. We are going to also set the origin, so we can do active el.origin, and this is going to be equal to, not that, this is going to be equal to pos 0 space, and we need a percent here. We do pos 0%, we do a space, we do another of these, and then we can do pos like 1, and that's going to give us these values. Let's see if we click, see if anything weird happens. So it's working kind of like fine. If you actually look at we're actually getting some position fixed stuff going on, and then it will remove itself later. So it's working really, really nicely. But of course, nothing is changing. So next, what we need to do is we need to enable the overlay. So we're going to set the overlay. We're just going to set it to not overlay. Kind of lazy, but it should work fine. But we're not actually, again, we're not actually doing anything yet. We're not animating any values. Both our opacity and our scale are determined by the springs that we set up. So I'm going to wrap this in a request animation frame call. And the reason I'm going to do this is because you always get a smoother animation this way if you just let your changes settle before you start your animation. Animations are very, very kind of tricky from a performance point of view. And making sure you're doing as little as possible while you're animating is going to give you the best chance of success. So I kind of want these things to settle. You could await tick, but I've generally had better results with a request animation frame call. So that's what we're doing. And inside of here, we're going to scale.set. And again, we actually need to calculate this scale because we can't just kind of multiply it by 2 because we have this margin to contend with. So we're actually going to calculate this. We're going to take the window width. We're going to subtract 2 because there is some other UI stuff that actually offsets the animation a little bit. And we're going to remove the left offset. We need 2 of those. And we're going to divide this by the width. And that's the width of the actual item. And that's essentially going to give us a percentage value, which is what we need for the scale. You know, we want it to be essentially full screen minus a little bit of margin. So we're going to do that. And hopefully this will work. And we can see we've got like some nice animations. Now nothing else is happening. But we do have this nice animation. We just needed to wrap this in parentheses, by the way, before we divided it. Order of operations, anyone? And the next thing we're going to do is we're going to set the opacity. So we're going to do opacity.set. And we're going to set this to 0.95. So we don't want it to be completely dark, but we want it to be mostly dark. And that's working really nicely. So we've got a nice little lightbox thing going on there. What we need to do now is we need to be able to kind of get rid of it. So we're going to essentially just implement this clear function. And again, it's pretty much the same thing all over again. So we're going to do the same thing. We're going to add a request animation frame call. I'm going to make this an async kind of function so we can actually do a bit of stuff inside of it. And we're going to await. So all springs return a promise. So we can just spring.set returns a promise. So we can just await them. So I'm going to promise to all the scale.set. We can just set this back to 1 now. Its original value. And we can set the opacity to 0, which is what it was previously. But of course, we still can't click. And the reason we can't click is because we still have our overlay messing around with things. So what we're actually going to do is we're going to reset the active EL to make sure it doesn't interfere with anything. And I've just got some defaults here. We're just essentially just going to set it back to what it was in the first place, like so. We don't need that. And then we're going to set overlay to false. I'm going to set this to true. It makes no sense to set it to what we're setting it to there. And now we can always guarantee that we're going to be on screen, relatively centered. We can see we've got a nice alignment in the center as well. And that's our application done. Now we've got this really nice, smoothly animated application. Not perfect. I think one thing to bear in mind when you're dealing with animations is when you're running things in dev mode, it's going to be a lot slower because frameworks include a lot of kind of dev time overhead. So when you're doing any testing, make sure you're testing in production mode. But this is pretty smooth for the most part, and it's feeling pretty nice. And we can kind of quickly cancel them. And it feels very responsive. It's also important to keep your springs and your animations pretty snappy. Users don't really like waiting around. We as engineers might think it's fun when we implement kind of these complex, long-winded animations. But realistically, you don't want to get in the way of your users. You're trying to improve the experience, not make it worse. We don't want to frustrate them by making them take a really long time to perform some kind of an action. Okay, folks, well, that's all from me. Thanks for listening, and I hope you found this useful.
Hey.
Oh.
Hey, Sean.
Hey. What's it going?
You're awake.
Did you make me live?
Yep, you're live.
Oh my god, I wasn't ready.
I'm sorry. Do you want me to remove you?
No, it's okay. Yeah,
all right, cool.
Yeah, good morning.
Good morning. So that talk was awesome, as always. Penguin is great at doing talks. I mentioned it already in the chat, but his talk on SvelteKit is also pretty good. So I'm just going to drop that here for people to look at after the conference, of course. Don't leave now.
You can also put it on
right.
on screen in StreamYard. If you have it in the comments, yep, there you go.
Yeah.
So just copy MT4CLV, whatever.
Yeah, that's easy to copy.
Cool.
Oh. All right. Yeah. So before we head on to the next talk, I'm just going to give a reminder that if you buy a ticket to Svelte Summit Fall before the conference ends, you'll be entered into a raffle and might win a seat at the speaker dinner. That's going to be before or after the actual conference. So yeah, if you're on the fence, I recommend buying your ticket now rather than later. You maybe get to speak to some of the speakers at the fall event. So that's Rich and Penguin and Amelia for now. Those are the confirmed ones, but there are going to be more, of course. All right. So yeah, that's it. So next talk, it's called Highs and Lows.
Oh, this is exciting.
Yeah, this is going to be a good one. And let's see here if I can find the actual talk. All right. Here we go. Okay.
Hello, Svelte Summit. My name is Bert Bengtson. I'm a lead developer at Ashley Furniture. If you are watching this video, then let me say, congratulations. You are thinking about or currently in the process of migrating a massive application to Svelte and SvelteKit. Soon, you will be using one of the most loved frameworks on GitHub as your JavaScript framework of choice. Let me tell you, though, that my team's success with Svelte didn't happen immediately because the NPM package takes 7 seconds to download. Yes, my team's journey as Svelte hasn't been an easy one, but it's been well worth it. Let me share with you our journey and some of the tricks we learned along the way, and maybe some of the bugs. A lot of the bugs. From humble beginnings. Now, you may think to yourself that because we went with Svelte that we would see success immediately in this project. And you'd be right. Thanks to Svelte's awesome dev tooling with things like Vite, Svelte Preprocess, and Svelte Adder, and also its superb tutorial, we were able to get a prototype running quickly, which got us a ton of support from the business and allowed us to continue. Yes, we were finally moving away from that old jQuery and onto something much better, more performant, and easy to work with. And with a few taps on the keyboard, we had a whole new project underway. Our codebase today. To keep up with today's demands on modern web applications, you need to make sure that no expense is spared on using the latest technology. This right here is our TypeScript of JS docs. It makes maintaining your code like 1,000 times easier for free. And these are Tailwind styles. You can add really easily as Svelte Adder, as you can see here. And it just makes maintaining styles across a huge code base like super easy. Oh, and these are the playwright tests. These come standard with Svelte and they're awesome. And lastly, can't go wrong with Storybook. It makes reusing components 1,000 times easier. Now, I know all this modernization would seem like it'd be confusing, but one of the great things about Svelte is that it makes integrating with these new technologies extremely easy. I think it's one of the best things about Svelte. So for this next section, I'm going to slow things down and teach you how to teach other people Svelte. Training. Now, you may be wondering why during this talk I am emphasizing Svelte's ease of use. Well, the reason that is because when you're doing these massive migrations, you need buy-in from the developers as well as the business. And developers tend to pick things they find easy or something they're familiar with. If you go Svelte for your migration, it's inevitable that you will have to teach a lot of devs Svelte. And here's some of my tips as someone who's done that a lot of time. First thing I would do in training new people is make everyone complete the whole Svelte tutorial. A lot of people try to speedrun it, but there's important stuff at the end like animations and actions that you don't want to miss. Now, the tutorial is probably the best there is out there for JS frameworks, but it doesn't magically make you an amazing coder overnight. With my project, we got a lot of code up and running quickly, but we were not in the phase of scaling out, and it all looked like this. Yeah, that's not good. Now, when you're coding for small projects, it's okay to be a little loosey-goosey with the rules. But when you're coding an enterprise application, thousands of people could potentially touch your code. And to keep it maintainable, you need some coding standard. Here are some of my suggestions that my team found the most success with. Number one is just standardize where things in Svelte go. Svelte is pretty open about where you put your variables, but maintaining things is going to be a nightmare if you have to go on a scavenger hunt every time you're in someone else's component. My team decided on imports, consts, props, let, functions, and reactive statements, with a special case for the creative dispatcher always being right after the imports. But your answer may be different. Now, I know this applies to all JS frameworks, but get all your developers on the same page on the naming conventions of your props. It'll make your code way more reusable and save your sanity. Two of my pet peeves are when people rename a prop that is ubiquitous in standard browser components, like this link URL prop here, or when someone adds the name of the component to a prop for no reason. We're in the product component. We know it's product text. This isn't all of them, and we're still refining them as we go. These patterns have handed upping their velocity and felt immensely. One quick note, it's a personal philosophy of mine, is that people are following patterns that might be too complicated or might not just be good. Patterns should be obvious and easy to follow. Lastly, I'd like to do a rundown on SvelteKit. It's an insanely awesome web framework that abstracts a lot of insanely hard concepts such as SSR and client-side routing. One thing I'd warn though, that it's still in beta, but it's not like anyone's hiding this fact. Our main problem with SvelteKit is that abstracting these hard concepts can be a blessing and a curse. If you have no one on your team who is aware of how modern web practices work, you could run into some problems. I knew we had a problem when one of the devs coded a SvelteKit endpoint and told me he wasn't full stack. Make sure people brush up on these concepts and share the knowledge. My team organized weekly powwows to share some of the knowledge love, and it helped us out immensely, and we all became experts in modern web practices quickly. Thank you for having me, Svelte Summit, to do a quick overview of my project and some of my lessons learned. Hopefully one of you guys can take something away when you're migrating one of your projects. I'm really excited to see where Svelte and SvelteKit have to go. But now for us, it's the biggest part of one of these projects.
I love that that last deploy. I wonder if it went well. Didn't look like it went well.
Someone in the chat said, "I love the Gojira voiceover audio sync." Was it out of sync? It was, right?
I don't know. I don't know.
Was that on purpose?
Who knows?
Rocky
Who
said
knows?
this took a ton of time, lol, way more than you think. So I'm going to choose that it's on purpose.
Yeah. I think like this is one of those talks that looks like it's almost a parody of like a truly bad one, but it's made so well that it's a good one. You know what I mean? It's super awesome.
Man. The other thing
Alright.
I'm really liking in the Svelte Discord is like people are recognizing each other from their own talks or talks that they gave in the past, and that's really cool. It means if you give a Svelte Summit talk, you are a celebrity, and people will recognize you.
A-list celebrity.
A-list celebrity, exactly. But it might be hard for Rocky because he has to talk out of sync, so he has to now. And maybe that's how people recognize him.
I mean, he's good. As long as he brings his chair, he's definitely going to be recognizable. I've never seen someone do a talk with a chair like that. That's pretty funny.
Yeah, no, like I call it. I'm thinking like no F's given essentially, but it's also like it's just like it's charming YouTube, right? Like that's how
absolutely
people edit, and like, man, I should just do more of that. Like, why am I messing around with this fancy camera with like the fuzz at the back? Like, we should just like use like really crappy green screen effects.
It's really nice. So it's I saw you wrote that you wanted to be able to edit videos like this, and so would I. It looks super fun.
Yeah.
Anyway, let's move on. We have the quiz now. Ooh, exciting. So let's see here. Ooh, it's the hardest Svelte quiz around. So are you guys ready? So the way this works is you just type out your answer in the chat, either on Discord or in the YouTube chat. And if you get all of them right, you win nothing other than you're known for being a good Sveltian. All right. So first question. When was Svelte 1.0 released? Oh, you're doing it.
I don't actually know the Jeopardy song. That's all.
Yeah, me neither. I just want like a heartbeat in the background, like doop, 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 doop. All right. Let's see here. What are we seeing? Are we seeing any answers? No one wants to play? 5.
Okay,
I guess everyone looked it up beforehand. So according to NPM, it's 5 years ago.
Oh, I got it wrong. I went for 6.
Yeah, me too. Yeah, same. But this is how it is. All right. People ready for the next question? Let's see here. What is Rich Harris eating in his Twitter profile picture?
Yeah, it's very classic Svelte question.
Yep, definitely. Is it ice cream? Is it a hamburger? Is it a pancake? Or is it pizza? Okay, I won't do the
I've never actually looked. All I know is he's eating something. It looks. I would have said something like a croissant or
Yeah.
Some
I think,
bready thing. The people saying ice cream.
Yeah. I like Penguin's statement here. What does he say he's eating? Yeah, I'm going to go with that answer. We'll see. We'll see. All right. So looks like most people are answering ice cream.
No,
ice cream?
there's a decent amount of pizzas. Rain Life says
Yeah.
iceberger pizza.
Iceberger pizza.
Dominic says black square. I don't know what the hell that is. Oh, okay.
Yeah. I have no idea. All right. So the answer is, do you know, Sean?
I think it's a folded pizza.
It is a pizza roll. Yes.
Yeah.
According to Rich, at least. Penguin seems to be skeptical of this. Yeah, sorry. Pizza cone, not a pizza roll. But yeah. All right. Next question. How do you listen to events in Svelte? This one should be easy.
How do you listen to events in Svelte? All right. I mean, there's wrong answers and there's right answers.
Definitely.
Oh, you forgot so you should have capitalized the E in on event. The second answer.
Oh, right. Yeah.
Ron says Svelte radio is how we listen to events in Svelte.
That's actually a funny answer. All right. So I think most people know that this is on : event, right? You were right, everyone that guessed this. All right. Next question. How many Svelte summits have there been?
Okay, this is a tricky
7,
one because
3,
you said
5, or 4.
You said past tense.
Yeah. So yeah. Sorry. So you count this one as well. That's a good catch. And it's a tricky one. It's not obvious actually.
Well, okay. And then the focus being on events called Svelte Summit.
Now you're giving away too much here, Sean. All right. So we have all sorts here. So 3, 4, 5, 7. I don't know, 7. That sounds very wrong. But yeah. So it's actually, drum roll, 5 or 4, depending on how you count. If you count the Svelte Society Day, it'd be 5. I think. Did I count this correctly?
Yeah, that's right.
Yeah. All right. And then I think this is our final question coming up. No, there are 2 questions. So what is SvelteKit? Is it the new Svelte version, a meta framework, a recipe for success, or a golden opportunity? Oh, let's see here what people are saying. Someone is saying all of the above. Others are saying meta framework. Yeah. No, you have to pick one. All of the above is wrong. So you have to pick one. Because it's not a new Svelte version, is it? Sorry, I gave that away.
Well, so I've often wondered if we can combine it
chat again
in some way.
Let's see here.
Silent Work says react without reacting. That's interesting.
Yeah. So, all right. Are you ready for the answer?
It's gonna be a mundane answer, right? I don't know.
It's definitely a recipe for success and nothing else.
Oh man, did anyone guess that? Nobody guessed that.
I don't think so. Yeah,
I got it wrong.
Yeah, I don't know what you were thinking, guys. It's definitely a recipe for success and nothing else. All right, next question. What is the best Svelte feature according to Kev? Stores, developer experience, two-way binding, or actions?
Yeah, I know the answer to this one.
Are you sure, Sean?
Yes, we've talked about it on the podcast.
maybe I've changed my mind.
Also, it's arguable whether Svelte has two-way binding, because I think people often sort of pitch that as a nice to have, and then React people always go, hey, isn't two-way binding bad? And I think the answer is a little bit more nuanced than that. Rich has a couple of Twitter threads talking about it. So I'd much rather say Svelte does not have two-way binding.
It just has nice bindings.
It has nice sugar syntax. I'll just put it that way.
Yeah. All right. So we're getting a lot of actions and we're getting a lot of developer experience. So this actually has two answers. I've started liking another feature a lot. So it's actually Stactions, stores and actions, as Ron Voluted said earlier today. But really, I do like actions more than stores. So it's actually the true answer.
Well, what do you like about what have you started liking about stores?
I just like the idea of extracting business logic and other stuff from components into stores in general. Yeah. That's pretty much the idea. We had a great talk earlier today about complex stores, and I was wrong. Sorry, it was very nice, super advanced, and I'll definitely have to rewatch that one. All right, so I think that was it. Yeah, that's it. You did it. If you had all of them right, you win. If you didn't, you lose. And I don't think anyone choose a recipe for success, so you all lose. Sorry. All right.
This is a rigged quiz. Only Kev can answer it.
Yep. I might be trolling you. Yes. All right. So our next talk is, let's see here. I have a list. Where's the list? Yeah. So the next talk is developer experience is for everyone. And that's from Brittney. Yeah. So bring it away, Brittney.
Bring the action.
Welcome to Developer Experience is for Everyone. I quit my job. Yesterday was my last day at Grainger. That's probably not how you expected a talk on developer experience to start, but during my short tenure there, we were able to accomplish some pretty amazing things, and I would like to highlight Grainger's journey with Svelte. Grainger uses a micro front-end approach, with separate teams creating each user experience. Svelte was vetted for 2 months against other frameworks, including Angular, Elm, Vue, and React. A small representative app was built in each one and voted on by 2 separate committees. Svelte was chosen for its performance, integrated styling and state solutions, no runtime dependencies, and its simple API with familiar syntax. Size in kilobytes was also a large factor. Svelte's bundle size is massively smaller than other frameworks. It also maintains higher performance by avoiding a virtual DOM and using vanilla JavaScript to interact and update elements. Svelte is also written with less lines of code for the same output in equivalent frameworks. Svelte had overwhelming support and was approved to move forward, continuing to evaluate the outcomes. I worked on the core engineering experience team. We were tasked with creating a Svelte design system that would cover any component that crossed between the different teams. During our time with Svelte, we created 11 components and a SvelteKit site that documented them with a playground to see variations and copy code snippets. We successfully helped 4 teams create entire user experiences in Svelte and SvelteKit: Keep Stock Web, Customer Insights, Order History, and Login. The Order History team was able to create the fastest time to market from concept to creation in Grainger's 100-year history. This was an incredible feat. Wait, not that kind. Yeah, that works. We were able to do that because of the amazing developer experience Svelte provides. Being able to write in a familiar syntax, we were able to quickly onboard new developers and jump straight into creating products that help our customers. Our productivity soared. As I mentioned, Grainger.com uses micro front ends, and that allows for various integrations of tooling. Currently, it is built primarily with React and Svelte, with some older Hybris jQuery in there as well. A decision needed to be made to align across teams on a single preferred framework that would allow for consistent components, tooling, and best practices. In December, Grainger made the decision to go forward with React. I know what we're all thinking, but this was the right decision for Grainger. A larger portion of teams were already using React, and a majority of the site was built with it. In the end, the trade-off was a larger bundle size and worse raw performance for a more widely used technology with larger ecosystem, larger hiring pool, and stability. I do advocate for using the best tool for the job, and for Grainger, that was React. Developer experience, or DX as we like to call it, is not the same for everyone, but it does affect everyone from the developer to the end user. What's right for me may not be what works best for you. Developer experience is the outcome of how a developer feels while using your product. Good DX doesn't get in your way, and you probably don't even notice it. It takes away the harder, repetitive parts of programming and provides a nicer approach with less overhead. Chris Coyer puts it eloquently. I like that good DX can be born out of clarity in the uncomfortable bits. Where are the rough edges? Tell me and you earn my trust. Hide it and you lose it. Bad DX feels like a frustrating user experience trying to bash your head on your keys to make it stop. Find those problems and fix them. I found this gem searching for bad developer experience and thought I would throw it in to show how we make progress. No product is perfect, and there's always room to improve. The pillars of good developer experience are documentation, support, and a simple API. But at the center of that is community, and Svelte has that in loads. An active Discord with threaded help channels to help provide support, Svelte societies in 9 countries and growing, and our newest group, the Svelte Sirens, a safe space for women, non-binary people, and allies to learn, build, and teach about Svelte. As developers, we look for shortcuts and tools that make our lives easier and make development more fun. That process allows us to iterate through and develop applications quicker, getting things to the user faster. We can find and fix bugs, test marketing strategies, and push to production faster. Providing a better DX means you're taking away the harder decisions, making a developer's life easier, producing faster for your customers, and providing the best outcome for everyone. Documentation, examples, and content around using your product are key. When designing tooling, find ways to give developers shortcuts, provide better error messages, and give helpful suggestions, and take away overhead. Svelte does all this plus helpful accessibility hints, less boilerplate, and a syntax that is familiar and able to be picked up quickly. So what's next for me? Time for the big reveal. I'm so excited because this place truly embodies great developer experience and has been the gold standard for me. I've used their product for years and am truly thankful to be part of such an incredible team. I've been patiently waiting to let everyone in on the secret, and if you know me, that is really hard. But now I can scream it to the world. This Monday, I will be joining the incredible team as a developer experience engineer at Netlify. I'll see you soon.
Oh, congrats, Brittney. I've been super excited to be able to talk about this. Very happy for you. Definitely.
Yeah, congrats on the new job.
Definitely deserve it. And now you get to work on Svelte. Yay.
Yeah, someone said, Granger switched to React, so she quit. Pretty much.
Yeah.
Pretty much what happens when you like Svelte enough.
Yeah.
No, I'm very happy for both Netlify and Brittney, and hey, it's my old job, so
yeah, exactly.
It's full circle. Yeah.
All right. So now we're going to go on a 5-minute break, and then we're back for Rich Harris's talk. Annoying parts. Well, what's the full talk title? Let's see. Annoying
next time
things.
Next time, just call it Rich Harris talk. That's it. That's fine.
Yeah, that's true. That's true. All right. See you in 5. All right. So it's time for what we've all been waiting for, I guess. It's Rich's talk.
It was a quick 5 minutes. Let's go.
Yeah, it didn't feel like 5, right?
I was getting my mascot.
It's almost a puppet.
Yeah, we need every
I don't
Svelte
have
to have
one.
a puppet. Anyway,
Yeah, that
I tried.
yeah, it's better than what I did. You know, maybe I should buy puppets for everyone for the fall event, so we can all like hold them up in the air or something. That could be fun.
Let's reenact
Also
all
sound
of Harry Potter with puppets.
yeah. All right. Let's put on the talk so people can enjoy Rich's hair. All right. Here's Rich Harris.
Svelte Loader, it's me, Rich, with a talk on annoying things about Svelte. This is going to be a two-part talk. The first part is things the Svelte core team has done that annoy you lot. And this is inspired by a post on the Svelte subreddit last week called What Frustrates You in Using Svelte. And I thought I would just go down as much of this list as time allows and look at some of these points and respond to them. Maybe in some cases explain why we made certain decisions. Maybe in other cases, who knows, figure out some to-do list items. The second part is going to be, just in the interest of balance and fairness, things that you lot do that annoy the Svelte core team, but we'll get to that. All right, so without further ado, what frustrates you in using Svelte? That I become sad at work when I have to use Vue instead of Svelte. I'm sorry, there's not a lot that we can do about that. Not much, honestly. I wish SvelteKit had better error messages when something went wrong. Next had really great debugging compared to SvelteKit. Yeah, this is true. We have decent error messages in some cases, but not all. I would say that this is kind of a natural phenomenon in software development. Like an error occurs when something has gone wrong, and the reality is you just cannot anticipate all of the ways that something is going to go wrong. Once people start hitting certain cases, you might find that you can provide a more informative error message than just throwing whatever error occurred. But in order for that to happen, people need to find it. And so a framework like Next, which has this ginormous user base and has been going for many years, its users have found all of those situations and have raised issues about them. And so I think this is one of those things that just kind of naturally gets better over time. So we definitely want better error messages in everything that we do. If you hit a situation where you have a cryptic error and you think that the framework could be doing something better, then raise an issue, because the chances are we'll agree with you. All right. The VS Code extension, code completion and formatting often don't do what I expect them to. Sometimes they completely mess up import statements and I haven't figured out why it works sometimes and sometimes not. So I think the VS Code extension is a marvel. Like, full disclosure, I don't totally understand how it works. It's maintained by smarter people than me. I just use it, and most of the time I find it works great. Occasionally it'll do something that's not 100% perfect, but on the whole it works pretty well. But if you do find that you run into cases where stuff isn't working well, then you can raise an issue. All of this stuff is maintained on the language tools repo, so Svelte.js, language tools. This is where to go. Okay, the only things missing from Svelte for me are error boundaries and each over iterables. Yeah, so error boundaries, what's meant by that is if an error occurs during rendering, it should be possible to recover from that. And at the moment, that's not the case in Svelte. You basically need to make sure that errors don't occur during rendering. This is something that we're definitely thinking about for Svelte 4. I don't want to make any strong guarantees, but it's something that I want, and it's something that lots of other people want. So, watch this space. Each over iterables. This is something that's come up from time to time, and if you're not familiar with this jargon, then it's probably easier if I just show you with a little demo. So say you had a map equals new map, and then map set A1, map set B2, and so on. It would be cool if you could do each map as entry, and then do something inside here, but you can't. That's not possible because the each block expects you to have an array-like object, and maps aren't, they're iterables. So you have to do this sort of thing instead. You have to convert it to an array first. And in there, I think it's something like entry there for the key, and then entry 1 for the value. Or you could use destructuring like that, and then reference key and value like so. Why don't I make this a little bit bigger so that you can actually see it? So yeah, it would be really nice if we could get rid of that. There's a reason that it's like this. The reason that we made that decision back in the day was when we're designing all this, iterables weren't really a thing outside the context of transpilers like Babel. In order to iterate over this object, you would need to use a for-of loop, and Babel turns that into some monstrosity with some pretty bad performance characteristics, or at least it definitely did at some point. That's not really the case anymore. Now, iterables are well supported everywhere, and this is something that I think we could do, and possibly something that we should do. Next up, the push for Edge serverless first. I had a working prototype with Sapper, which is SvelteKit's predecessor, which only ran on Node, and then important Express middleware, which is a hard requirement. The switch to SvelteKit happened and screwed me completely over. Well, I'm sorry about that. That's definitely not what we want. It is possible to run SvelteKit as a Node app. We're still figuring out the best way to accommodate things like Express middlewares that do, frankly, some quite naughty things with the request object before passing it to your middleware. We want to be able to expose those things. So if something adds like rec.session or rec.auth or whatever it is, then we want to be able to surface that. But we want to do so in a way that is sensible and isn't going to be a design footgun further down the line. So bear with us. We will have a solution to that. The whole Edge serverless first thing, though, that's not just us. Like, the entire industry is moving towards this model. And that's because it has some very concrete advantages to the old way of maintaining your own node servers. Right now, I think there are probably more apps running on Node servers, but the growth charts when you look at serverless and Edge are just extraordinary. And it's important to skate to where the puck's going to be. We want to be able to accommodate users who don't want to have to worry about maintaining their own servers, and serverless and Edge have some very desirable characteristics, and we think that this is the right choice. We think this is the way that people are going to be building apps for the foreseeable future. I know it's syntactic sugar, but I'd like a switch block. It feels primitive to chain if-else's. Yeah, okay, let's think about this. So let's go back to our REPL. Let's say we've got let thing equals whatever, make it a prop. And you might have if thing is foo. So how would we do this with switch syntax? Well, we'd begin with switch thing, obviously. And for the remainder of this, we're going to have these errors down here because this is invalid syntax, but this is just for an exploration, so we'll ignore it for now. We need to get the cases in here, and maybe these are blocks, like case foo. But that's going to feel quite laborious after a while, right? Because we've got one for each of these. That's quite a lot of markup. So I don't think that's going to work. But maybe we could take a leaf out of the else tag here and turn that into a case foo. and then maybe case bar, and then maybe case bars, and then default. It feels a little bit weird that every other time we have a block that has these continuation blocks like else or then and catch in the context of an await block, they're all flush left. They're all at the same level. So maybe if we just get rid of that indentation, this part looks a little bit weird. Maybe we put the default up here like that. So everything until the first case is the default, and then we start the case. I kind of don't hate it, honestly. We've also got the situation where there is no else. There's no default fallback, in which case we wouldn't have that. And then maybe we do the same thing that we do with await blocks when there's no pending state, when you only want to have you wait for the promise to resolve and then you show something. So we would do like that. Yeah, maybe we should do this. I don't know. Sound off in the comments. Tell us what you think. SvelteKit configuration needs to be simplified a lot. Should be a list of options in the CLI setup tool. Do you want a static pre-rendered client or a full client server with endpoints? A simple SPA option would be nice too, because some people still need to write them. I get where this is coming from. I do, particularly if you're just getting started. It's nice to not have to understand what the configuration is doing before building your site. But I think this is one of those things that's seductive, but ultimately would be a mistake. And here's why. Very often you don't know what you need to build until you're actually building it. And what I find with CLIs that give me a list of predetermined options is that I don't understand the difference between them. Like, I know how to create a completely static site, or I know how to create a fully server-side rendered thing. I know how to do the Node version or the Cloudflare version or the Vercel version, because these are options that are in my CLI. But then what if I change my mind? What if I need to change something afterwards? Then my job of figuring out how to do that is much harder, because I don't understand the differences between these different starting points. And so, for example, you're building something that you think is going to be a fully static site, but then it turns out that you need something dynamic. It might not even be dynamic server rendering. It might just be that you need to add an endpoint to do some proxying or something like that. If you've started with the static site preset and you don't have the configuration options that SvelteKit has, and instead you need to go back and recreate it as a partially dynamic site or whatever it is, then you've lost. We think it's better to have some configuration that exposes all of these controls in a way that is consistent and documented, and that you can change to meet the evolving needs of your application. I do agree that we could probably make the onboarding a little bit simpler. We could have more examples than just the demo app or the skeleton app. And that's something that we'll probably get to for 1.0. But in general, I think even if the configuration does take some learning, it's a better approach than having presets that are then hard to work with when you discover that your needs have changed. Love Svelte, but missing all the ecosystem of React for sure. Yeah, we can't fix that overnight, unfortunately. That Svelte docs don't have a search bar. Yeah, so at the moment, the Svelte documentation is one single giant page, and if you want to find something, then you just have to press Command F and search for it that way. The SvelteKit docs, on the other hand, do have a search bar, and it's split into multiple pages. So instead of using Command F, you'll use Command K, and you get much better search. And I think what we'll probably do is we'll backport this search function to the Svelte docs, because I agree, it's much easier that way. All right, what a comment about syntax. Everyone loves to talk about syntax. I forget the syntax every time, even I'm not sure right now. In Django template is much more simple for X in Y and then end for. Like I personally recoil at things like end for and end if. It's not quite as bad as bash, where you have if and then you end an if block by writing phi, which just boggles my mind every time. But it's still a bit weird. I think having a closing slash kind of makes sense in the context of a language that extends HTML, because that's how you close an element. It just kind of flows naturally. But look, everyone has different opinions about syntax, and none of them are correct because it's all basically subjective. But what I will say is that syntax in Svelte has, let me just pull up the issue. So this has been bike-shedded more than just about anything else in the framework. This is a very old issue. Between Svelte 1 and Svelte 2 is when we started having this conversation. And it goes on forever. Like, every possible combination and permutation has been considered at some point, and this is what we landed on. And so the chances are, if you have a different idea for syntax, we've already considered it, and there was some reason that we couldn't or decided not to do it. Currently nothing in Svelte itself, only SvelteKit, as the docs are not so good. Yeah, guilty. The reason for that is, like, we haven't done any kind of interactive tutorial for SvelteKit yet. It's going to be a big undertaking, and it's something that we're definitely going to do before we get to 1.0. You're just going to have to bear with us for that. The lack of a comprehensive UI library, again, there are a bunch of UI libraries out there, but ecosystem stuff just takes time. Single biggest frustration for me is that Svelte is not a standalone compiler. I'm forced to use some garbage bundler. So in version 1 of Svelte, we actually had a Svelte CLI, which did compile Svelte components into JavaScript modules, and we got rid of it for a good reason, which is that what that compiler essentially had to do was it would inline all of the internal library helpers that your component was using so that your Svelte file could be used as a standalone JavaScript module without dependencies. And it doesn't really scale very well. We found that people were doing that like almost out of laziness, and it was resulting in bad end user outcomes. So you should be using a bundler. Like, if you're building anything, you should probably be using a bundler, because that is the way to deliver the best outcome to your users. But you can use Svelte as a standalone compiler. In fact, on the main Svelte docs, we have a compiler API that you can play with yourself. It's just that normally this stuff is abstracted away because you're using a bundler that has a Svelte plugin, and it just happens automatically behind the scenes, but you can do it yourself if you want. Nothing is stopping you from doing that. All right, this is a big one. It's a SvelteKit thing, but I really dislike how heavily server-side rendering is pushed. Search engines do actually run JS, so CSR isn't a big deal for SEO. I'll come back to that. And the slower first page speeds do negatively impact Google's search rankings. Okay, there's a lot going on here. We do heavily push SSR, and that's for 3 reasons. SEO is one, but the other 2 are performance and resilience. So on the SEO front, yes, Google does run JavaScript. Google is not the only search engine bot out there, but it is the big one. And it does run JavaScript, which means that if you have content that is injected after the page has been loaded, then it can get indexed. And while I don't have any inside knowledge of how search engines work here, what I've gathered over the years is that this process is less reliable, and it will happen less frequently, which makes sense because it uses a lot more resources to open a page in a headless browser and execute JavaScript than it does to just scan the HTML and index it. So the advice that we've been given over the years is that you should do server-side rendering because your content will be indexed more reliably, more efficiently. And in fact, there's a page I have up here which I will drag in so I can highlight some stuff for you. This is from a page by Google on understanding JavaScript SEO basics. And there's a couple of interesting snippets here. Once Google bots resources allow, a headless Chromium renders the page and executes the JavaScript. Okay, so once again, it's about resources and whether or not we have the bandwidth to do so. Keep in mind that server-side or pre-rendering is still a great idea because it makes your website faster for users and crawlers, and not all bots can run JavaScript. So putting aside the not all bots can run JavaScript thing, what this is saying is that SSR is good for performance, not bad as the commenter suggests. And this is something that people pretty much universally find. SSR is good for performance, and that's for a couple of reasons. First of all, it's good for perceived performance because seeing a blank page and then seeing content flash in makes you think that things are slower than seeing some content immediately when the page loads. But it's better for actual performance too. Like if you think about, here's a browser and here's a server. If you're getting a blank page with some HTML and CSS and JavaScript, taking that back to the browser, running the JavaScript, and then fetching some data from the server, then you've got to do these two sets of round trips. But if instead you go to the server and the server gets data from itself or from somewhere else in the same data center, that's basically instantaneous. And so you can send that back to the client fully formed. And so you can get content in one round trip instead of two. That's a simplification, of course, but the general principle is that server-side rendering will make your site faster. And that is one of the reasons that we push SSR so hard in SvelteKit. Finally, resilience is really important too. JavaScript fails all the time for reasons that are completely outside your control as an application developer. People with spotty connections, or people on weird Wi-Fi networks with bad configuration, people on browsers that don't support the JavaScript you're running, people looking at your content on something like the Internet Archive years after it was initially created. All of these are perfectly valid use cases, and in all of those cases, those sites will only work if you have server-side rendering. So for the combination of those three factors, we think that SSR is the correct default and that you should only opt into SPA mode when you have a really, really good reason to. All right, I've gone way over my time budget, so I'm going to stop there, even though we didn't get through everything. Thank you to everyone who contributed to this thread. It's really useful. Just in general, feedback like this is super helpful for maintainers. So please keep it coming. I'm going to go and get some lunch, and then I'll see you for part 2.
Let's enjoy an intermission. You'll find our snack bar chock full of good things to eat and drink. Tasty, tempting hot dogs, thirst-quenching soft drinks, fresh, crunchy popcorn, a complete assortment of delicious candy, and a full line of cigarettes.
All right, part 2, time to turn the tables. So there's really only one thing that I want to talk about, and it's a bugbear that I share with basically all open source maintainers, and it's around reproductions. Sometimes people open issues on open source projects and they're asked to provide a reproduction, and they either don't or they create a bad reproduction. So what I want to talk about in this section is why repros are important and how to create a good one. Now, when you open an issue on SvelteKit, you're presented with this issue template. And one of the sections here is the reproduction section. And I'm going to read it out verbatim. A link to a repository or a fork of node.new/SvelteKit that reproduces the issue. Reproductions must be short, self-contained, and correct, and must not contain files or code that aren't relevant to the issue. Please do not just paste a link to your project. Explaining how to reproduce is generally not enough. It pushes the burden of creating a reproduction project onto a small set of volunteer maintainers and isn't scalable. If no reproduction is provided, the issue will be closed. Now, frankly, we're not all that militant about closing issues without reproductions, but we probably should be because it would increase our development velocity. The worst offenders are people who open issues and choose not to provide a repro, often saying something like, "This is simple enough that I don't think I need to provide one." This is kind of like going to someone's house and being asked to take off your shoes and deciding to keep your shoes on. You know, you might be thinking, my shoes are cleaner than your carpet, but it doesn't matter. You've been asked to take your shoes off, and you'd be a sociopath not to. And that's kind of what it's like when you disregard the instructions in the issue template. It's a little bit rude. The thing is, it's in your interest to create good reproductions. And that's for a couple of reasons. Firstly, any moderately popular open source project will get a lot of issues. A few days ago, SvelteKit had somewhere around 400. I've been aggressively triaging over the last few days, and it's closer to 300 now, but it's still a lot of issues. And each one requires a lot of time and effort to deal with. And we're grateful for these issues. We're glad that you've chosen to open an issue, but at a minimum, it's going to take a few minutes to look at the issue, understand what's going on, develop the context, and either close it, which means writing a message explaining why it can be closed, or writing a pull request with tests and everything else that goes with it in order to close it the hard way. Either way, it's going to take time. Let's say it takes 10 minutes on average to close an issue. If you have 400 issues, that's 66 hours of non-stop work. There's only 40 hours in a work week, so that's a week and a half of doing literally nothing else. But the reality is that 10 minutes is way too optimistic. The average issue, I would guess, takes somewhere between 45 minutes to an hour to close. If it's an hour and you have 400 of them, then that's multiple weeks of doing nothing but closing issues. And in that time, more issues are going to come along. It's very true that issues with reproductions get closed faster than issues without reproductions because they're easier to fix. And so if every issue has a good reproduction, the time that it'll take us to close them all and release SvelteKit 1.0 is going to be reduced. So between us, if we can all create good reproductions, that's going to help everyone. But it's also beneficial for you as an individual because as maintainers, we prioritize issues with good reproductions. It's partly a question of gratitude. If you've put the effort in to make the issue really easy for us to fix, then we want to repay you. We want to thank you by prioritizing your issue. But it's also just because I know that an issue with a good reproduction probably isn't going to be a giant rabbit hole, and I want to use my time profitably. So I'm more likely to pick an issue from the tracker that has a good repro. So for all of those reasons, please do provide a reproduction. And then there's the issues that do have a reproduction, but the reproduction is overly complex, or it includes things that aren't relevant to the repro, or it doesn't have instructions. And that's almost as bad. So in the next few minutes, what I'm going to do is talk you through what a really good reproduction would look like. So let's say you found an issue relating to how URL parameters are encoded in a SvelteKit app, specifically that they're different between server and browser. And you want to create a reproduction that shows this. The first thing we're going to do is create a project with a distinctive name. I'm not just going to call it SvelteKit bug, because then when I clone your repro locally and put it with all my other repros, maybe there's going to be a naming conflict, or it's just going to be harder to juggle with all of the other things that I'm working on at the moment. So good project names is a really good first step. I'm going to call this SvelteKit URL params encoding issue or something like that. CD into that directory, and then I'm going to create a new repo using npm init svelte. Right, I'm not just going to take my existing project and add a branch to it that shows the problem. I'm going to start from a fresh project because that's the best way to not include all of the extraneous stuff that isn't going to help the reproduction. I'm going to create it in here, create the skeleton project. I'm just going to pick all of the defaults here. I'm going to install dependencies with npm. I know some of you like to use yarn. I like to use pnpm, but a good baseline is to use the same package manager as the ecosystem at large. And in JavaScript, that means using npm. By doing so, it means that you're going to check in a lock file, which will enable any maintainer to recreate the state of the reproduction at the time with the versions that you were using when you encountered the bug. If you use yarn and you check in a yarn.log file, then you're forcing maintainers to also use yarn. And a lot of maintainers don't use yarn. We use npm. I personally use pnpm, so I'm happy with a pnpm lock file, but a package-lock.json is the gold standard here. Let's open this project. I'm going to start my dev server, open that up. And then I'm going to create a route that demonstrates the issue. Call it test/params.svelte, and we'll give it an accompanying endpoint, params.js. Right, and we'll write some code that shows that the params from the server match the params from the browser when we have a simple parameter like foo. If we then add some links that show the bug, then we can immediately see the problem. And then the last step is to put this repository on GitHub and link to it from your issue along with some instructions on how to see the bug. And that's all it is. That's all that's involved in creating a simple reproduction. Now, I cheated a little bit. This reproduction is one that I stole from an issue that is currently open on the SvelteKit repo. It was submitted by Bluebee, and it is an absolutely perfect example of how to do a repro. So Bluebee, you're awesome. Everyone else, be more like Bluebee. Okay, here endeth the rant. Thank you for everyone who does submit issues with reproductions. It truly is appreciated. And thank you everyone for watching this talk. I'll see you around.
All right. So that was a lot of annoying things about Svelte.
The annoying thing is us. I definitely have an issue without filing a repo, but I was, in my defense, it was a feature request.
Yeah, I guess that's a bit different. Hard to reproduce a feature request because then it would already probably be a feature, maybe. Yeah. Cool. All right. I saw you had a guitar there for a while. Were you gonna play a Svelte theme song for us?
I'm not ready to play a guitar. The place I'm staying at has a guitar, so I was just picking it up and playing it while watching talks.
Oh, nice, nice. Here I was hoping for a Svelte theme. Maybe next time.
Maybe next time.
Yeah. All right. So that's all of the talks. So again, a reminder: if you buy a ticket for Svelte Summit Fall before the conference ends, so I guess I'll give it an hour extra for you guys. You get to maybe have a free dinner with the speakers at the speaker dinner. So yeah, the tickets are transferable but not refundable. So if you know someone else that wants to go, you can buy a ticket for them and transfer it to them and give them the chance to have a nice dinner. But yeah, so I hope you all enjoyed Svelte Summit again. And I guess I hope I'll see you all in Stockholm in the fall.
Yay.
Yeah. Exciting. It's going to be awesome.
Congrats on the 5th event. Yeah, the Svelte community is awesome. Let's catch up to Discord.
Yeah. So we're going to create a temporary stage hangout channel on the Discord. So if you want to talk with people after the event, you should join the Discord. So that's discord.gg/Svelte. I'm going to drop a link in the YouTube comments, like so. So yeah, I'll see you all there.
All right.
Bye, everyone.